Hello guys, how you are doing? Just tell me. How your exam went? You just tell me. How you are feeling right now after giving physics examination? Did you gain any confidence about it, about the board examination? What is your situation in chemistry right now? Just let me know if you are tensed, if you are very much scared about the subject chemistry. What is your I mean to say condition right now? Just let me know and let your friend know about your condition. You will see your competitors present over here in this video only. Okay, so basically today I have a plan to go with 30 MCQ. Okay, and I can guarantee you, yes, you will get MCQ also common. Okay, so keep faith. So go with me up to the end. I am here with a full energy. I want you people to be with full energy, complete charged up. So yes, we can go ahead. What do you think? Should I go ahead? Okay, I can see Dhanalakshmi is very scared. Okay, some of you, okay, it was hard. Okay, don't worry. So first, whatever, before you are studying for a new chapter, it's very much important that you should come out of a previous exam trauma. Okay, maybe it was good, maybe it is bad, whatever it was, just forget that. Delete that particular thing from your brain and please focus on the chemistry. I know many of you, they get scared about chemistry, means the most difficult thing, most difficult subject, that is chemistry. Please don't think it like that. Take it very lightly. Yes, take it very lightly and follow strategy. Okay, and this is not the time when you should read thoroughly the concept. Don't go for that. Okay, don't read thoroughly. Please go with a strategy. Do some smart work. Okay, yeah, let's go ahead. Yes, simple beauty. Yes, definitely this session is more than enough to get 20 marks. Yes. Okay, let's go ahead. Okay, study full energy, full FLL, full. Okay, got it. It's to taunt me or taunt your people, taunt your friends, I don't know. Anyway, let's go. Okay, so first few first few MCQs I will go really fast. Okay, let's say 40 to 45 numerical I will go really fast because those numericals are very well known to you people. Okay, and you will guess from where I will get it. Okay, so yeah, so answer I want you people to tell, and I will go really fast with first 40 to 45 MCQ, then extra MCQ we will do. That will be almost 200 250 plus MCQ that will do extra to give them the support. Okay, so yeah, let's go ahead. This is the first question. I want you people to answer me fast. Don't ask me for the class timing. So see, I am here with a full energy, full confidence, and I know you people are also with the full energy. So yes, if you want me to teach you properly, if you want me to guarantee you for the full marks, 70 out of 70 if you watch the last 2 to 3 days video, means today's video, tomorrow I will come up with the numerical problem, then physical and inorganic completely, day after tomorrow I will come up with the organic chemistry. Not only that, in the evening, Sunday evening, I will come up with a full final revision. I will not take that much time. I will take only 1.5 hours or 2 hours max to max in the evening, Sunday evening, full chemistry revision. And you know what? That is also not the end. I will come again on your exam day morning 4 o'clock. Yes, I will come up with a live session morning 4 o'clock for a last time revision. So yes, I will be there till end. I will be standing with you people during your whole preparation. So don't think that you are alone, you are preparing, you are working hard only. But here I am, who is also working hard with you people. So yes, let's get started. So the mass percentage W by W of glucose in water is 10%. It means 10 gram of glucose dissolved in 90 gram of water. Sometimes what happens, you know these questions very well, but they can shuffle the answers, right? They can shuffle the options. So be careful about it. So option D is going to be the correct one. Let's go ahead. Okay, which of the following elements is liquid at the normal temperature? So that's gonna be element. Okay, be careful again, I'm telling you, go through the full question properly. element, don't go for the water. Water is also liquid, so you may have a tendency to mark the water. Okay, so correct answer is mercury. Next, the reagent used for the Sandmeyer's reaction, Cu2Cl2 and HCl. Okay, let me give you a little bit hint here, not hint, basically it's a trick. So CuCl sometimes they may ask, CuCl they can give the option. So check whether the oxidation state of copper is +1 or not. Okay, what I said, for Sandmeyer's reaction, your copper oxidation state must be +1. Okay, so this is the option. Next, the main natural source of acetic acid, that's going to be vinegar. Next, the reaction of aniline which produces zwitter ion as a major product. So basically, if you do the sulfonation by giving concentrated H2SO4, then you will get this type of compound, right? NH2 in the para position, SO3H, right? So what it does, let me show you here. It basically gives one H plus and NH2, it takes up that H plus and it forms NH3 plus. Okay, so they are in equilibrium. Okay, so that particular thing is basically the zwitter ion, the charge separated version. Okay, so sulfonation is the correct answer. Let's go ahead. Okay, very good. I can see so many of you are giving answer. Very good. Okay, I can see those people as well who is giving wrong answer and then deleting. So don't do it. Okay, let's go ahead. The method used for the separation of isomeric product obtained when phenol reacts with dilute HNO3. So what you will get? You will get orthonitrophenol and paranitrophenol. So orthonitrophenol and paranitrophenol, how you can separate? It is steam distillation. So yes, let's go ahead. The ligand which forms more stable coordination complex, that's gonna be Cn minus. Don't make the mistake with the carboxylate. Okay, it's gonna be Cn minus. Let's go. Which of the following groups when present at the para position increases the basic strength of aniline? That's going to be NH2 because this is my electron donating group, right? Let's go ahead. Okay, in the following acid, vitamin is ascorbic acid, that is of vitamin C. Okay, let's go ahead. The best reagent useful for the separation and purification of aldehyde from ketone, that is basically sodium hydrogen sulfide. Very important. Okay, very important question. Go ahead. Statement 1. On mixing the two liquids, the solution becomes hot. It implies that it shows negative deviation of Raoult's law. Definitely, if it is hot, means exothermic, means delta H mix is less than 0. It means negative deviation. That's completely correct. Next portion, you can see solution which show negative deviation accompanied by decrease in volume. So definitely that also will be accompanied by delta V mix negative. So both the statement are true. So option A is going to be the correct one. Okay, let's go ahead. Okay, match the following. It's a very important question, I'm telling you, my dear. It's a very important question. Okay, don't miss this type of question. Okay, so transition metal compound TiCl4 plus AlCH3 whole 3, that is basically which reagent? Just what is the name of this particular what it calls catalyst? Just give the name here. Okay, someone is asking why so fast? Because these are known to you, my dear. From where I'm taking? From the model paper I'm revising, the MCQ. Then we will go slowly when new MCQ will come. So first 45 I will go fast, super fast, and then I will be slow down. Okay, so yes, so this is basically Ziegler-Natta catalyst, right? Ziegler-Natta catalyst, right? So Ziegler-Natta catalyst is used for the polythene manufacture. Next, PDCl2. PDCl2 is for what? PDCl2 is for Waker's process, right? It is A. Nickel is for hydrogenation of fat, that is D. Vanadium pentoxide is for the contact process for preparation of H2SO4. So CADB. Option A is the correct one. Okay, go slow. Okay, I'm going slow. Don't worry. Okay, I'm not giving you the time to answer. Okay, I'm going slow. Okay, calm down. Okay. Yeah, A and B are same, but don't worry, in your examination they will not do the mistake. Don't worry. Okay, let's go. Okay, so just tell me, what is the answer of this question? The common oxidation state shown by the element with atomic number 21. So atomic number 21 is basically scandium. Okay, scandium shows +3 oxidation state, right? Okay, very good. I can see what a complicated name with Q. Okay, so very good for giving the first test answer. Let's go. Next question. Which of the following is homoleptic complex? So what is homoleptic complex? Homoleptic complex is if the metal is attached with the same type of ligand. Okay, so homoleptic complex is, tell me the answer for this. Fast. What is the answer for this? Homoleptic complex. Okay, I can see the correct answer from Gia. Very good, Gia. So option D is going to be the correct one, right? Because you are having only amine, 6 amine attached with cobalt. Let's go ahead. Okay, so what reaction is this? First, give the answer. Fast. Okay. So basically you don't have any competitor. All of you know the answer. So if there is no competition, then how should I proceed? Okay, so for this case your answer is going to be the Finkelstein reaction. That is option A. Let's go ahead. Okay, the chemical formula for the Hindenburg reagent. So you can have, like, they can deviate you by doing, like, by giving you wrong formulas over here, COCl2, like SOCl2, like this type of things they can give. So be careful. The formula is something like this: benzene with S, double bond O up, double bond O below, here Cl. Okay, SO2Cl. Okay, so this is the correct answer. I guess today visibility is proper. Okay, because it is a black background, I guess it is clear for you today. Okay, next let's go ahead. Okay, okay, so many of you are giving correct answer. Oh my god, there is no competition at all. Let's go ahead. Doctor advised a 50-year-old woman enough exposure to sunlight and addition of fish and egg yolk to her diet. Name the vitamin deficiency. Yes, 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 tell me the answer. It's going to be vitamin D, right? Okay, okay, very good, distortion. Okay, let's go. Salicylaldehyde can be prepared from which of the following reactants? Yes, salicylaldehyde can be prepared from which of the reactant? That's gonna be option B, phenol, chloroform and NaOH. Very good. Okay, someone gave the answer D. R, A star, something the name is. Okay, so beta, the answer should be vitamin D. Okay, be careful about it. Okay, let's go ahead. Okay, so for this question, tell me the answer. Last time when I did, few of you gave the wrong answer for this question. So this is related to Saidzev rule. Okay, this is related to Saidzev rule. So basically you have CH3, here CH, here hydrogen, here CH, here Br. You are having 2 beta hydrogen, here also 1 beta hydrogen. So you can get one product like this. So you will get the double bond out there, right? CH, double bond, CH, CH3. You can get it like that or this path. Okay, so these will be your minor product. CH3, CH2, CH, double bond, CH2. So this is going to be your major product. Why? Because of the Saidzev rule. Okay, so what is the formula of this compound? Yes, what is the answer? The answer is going to be D. Very good. Okay, 2-butene. Let's go ahead, let's go ahead. Okay, very good, very good. Okay, hi Madhu, Harish, very good. Let's go ahead. Some of you are giving C. Why C, my dear? 1-bromobutane. No, beta. There will be no bromine. This is basically the concept of dehydrohalogenation. Okay, let's go ahead. Statement 1. Benzylic alcohol. The OH group is attached to sp3 carbon atom next to an aromatic ring. So basically benzylic alcohol, if I draw, it is basically CH2OH. This is benzylic. Okay. Next, vinylic alcohol. Vinylic alcohol is C double bond C directly attached with OH. Okay. So this is basically, yes, definitely it is sp3. So statement 1 is correct, and vinylic alcohol OH group is bonded to a carbon atom of carbon-carbon double bond. Yes, that is also true, but it is sp2. Okay. So both of them are correct. Option A is the correct one. Okay, very good. Okay, let's go ahead. Okay, this question I have done multiple times. I want you people to give answer directly. Okay, so if you write the rate equation, just multiply this later and you will get the answer. Okay, in case you don't know, then comment me below. I will do it in front of you and you will see that. Okay, answer me for this quickly. Okay, I can get the answer A. Very good. Let's go ahead. Okay, I can see Harsha. Yes, beta, question bank MCQ also we will do. Everything will be covered. You will get 20 marks sure shot. Okay, let's go ahead. Okay, for this case, this is a very important question, my dear. It's a very important question. Okay, so this is basically unit you have to match. Okay, so G star is basically centimeter inverse, that is B. Kappa is basically Siemens centimeter inverse. E cell is basically volt, and that is going to be Siemens centimeter square mole inverse. Okay, so what is the answer? This is my B, this is my A, this is my D, this is my C. CDAB, where it is CDAB. Option B is the correct one, right? Okay, option B. Very good, very good, very good. I can see correct answer is given by Kiran. Very good. Okay, let's go ahead. Okay, I can get a question. How to get 70 out of 17 chemistry? Hard work, dedication. Okay, anyway, so if even you are studying today itself, my dear, please continue till end. Your MCQ will be sorted. Okay, tomorrow join the live session. New medical will be sorted. Again in the evening with me, physical and inorganic, that will be sorted. Next day morning, organic will be sorted. Okay, next you do the revision. Last question, which one? This one, I guess. Okay, let me do it for you, my dear. Okay, rate of reaction, if I do minus 1 by 2 d of A by dt, okay, equals to minus 1 by 3 dB by dt equals to minus 2 into dC by dt. This is the rate of reaction. This is how you write. Now you have to multiply this here, these here as well. So see, this is minus 2 by 3 and this is minus 4. I guess this is clear now. Okay, so let's go ahead. Okay, just tell me this answer. Hydration of acetylene. Acetylene means you have ethine, this particular thing. This particular thing. If you give H2SO4, H2SO4, HgSO4, this is basically oxymercuration, demercuration. Important question, okay? Oxymercuration, demercuration. Oxymercuration, demercuration initially will give you the alcohol, okay? So it is expected that it will get something like this. You will get something like this, but don't stop here. If you stop here and if you check the name, okay, and if you just write it out, then it will not work. So further it will undergo ketoenol tautomerism. So basically it will undergo tautomerism. Okay, tautomerism, if it undergoes, then you will get CH3CHO aldehyde. So you will end up with acetaldehyde. Okay, so yes, very good. I can see the answer C. Very good. Okay, let's go ahead. Let's go ahead. Yes, Harsha, I can assure you 20 out of 20 if you don't do silly mistake. Okay, now silly mistake is not in my hand, my dear. Okay, let's go ahead. Next question is this one. Okay, So 10 ml of liquid A and 20 ml of liquid B are mixed at 25 degrees Celsius. The volume of the solution was measured as 30.1 ml. So this is a little bit tricky one and also important one. Okay. So wherever I am marking, wherever the question, whatever the question I am marking, please थोड़ा ध्यान से देखना, ठीक है? It's important actually. Okay. So 20 plus 30, if you just add them, it will give you 20 plus 10, sorry. 20 plus 10, if I add, you will get 30, but you are getting 30.1. 30.1. It means delta V mix means change in volume after mixture. Change in volume after mixture is greater than 0. Greater than 0 means positive deviation, right? Positive deviation means delta H mix is also going to be greater than 0. Okay, so option C is going to be the correct one. Okay, very good, very good. Okay. Let's go. Very good. Okay, for this case, so what do you have to do? You have to check the spectrochemical series of the ligand. What do you have to check? The spectrochemical series of the ligands, ligand field. So cyanide will come first, then water comes, then F comes, then Cl minus comes. So in accordance to that, if you check, you will get the answer. So I guess option D, no, option A is the correct one. Okay. Okay, very good. Undefined gave the answer, very good. Let's go ahead. Yeah, this question, I want you people to answer. A binary solution has two components A and B. The mole fraction of component A is 0.5. Then the number of moles of the component A and B in the solution is, if mole fraction of one is, one component is 0.5, so another component must be 0.5 in order to make the summation 1, right? So your answer is going to be C. Okay, Ajay Pawar. न्यूमेरिकल पूरा सॉल्व किया मैम, बट उसका आंसर रॉन्ग आ गया है, पर बोर्ड में मार्क्स कितना मिलेगा? डोंट वरी, बोर्ड पीपल आर देयर टू गिव यू मार्क्स माय डियर, सो don't worry about the answer. Make sure you are writing the formula. It's very important, my dear. Writing the proper formula will give you 1 mark. Okay, then substitution, correct substitution of the values will give you another 1 mark. So out of 3 marks, 2 marks you got there. Then after calculation, proper answer along with the unit will give you 1 mark. So अगर आपने proper formula लिखा है, substitution ठीक से किया है, तो फिर आपको 2 मार्क मिल जाएगा. ठीक है, स्टेप वाइज आपको 2 मार्क मिल जाएगा. अगर आपका लास्ट का आंसर गलत भी आ गया तो छोड़ो, 2 मार्क आपको मिल जाएगा. ठीक है, ओके चलो लेट्स गो. The reagent which does not react with both acetone and benzaldehyde, tell me the answer. That's going to be Fehling solution or sodium hydrogen sulfide. Yes, tell me. So Fehling solution is very mild oxidizing agent basically. So it can only react with aldehyde. It cannot react with ketone. Okay. Very good, Jia. Very good. Very good. Okay. So Nandan is saying chill, bro. I also tell my student to chill actually. Okay, let's go. Okay, this is your fill in the blanks. Let's do fill in the blanks. Okay, Van 't Hoff factor I for a non-electrolyte. So non-electrolyte solution cannot dissociate. Okay, so in case your solution cannot dissociate, your Van 't Hoff factor will always be 1. Let me give one example. Sucrose, fructose, urea. Okay, if you see this type of questions, this type of electrolyte, they cannot dissociate, right? So Van 't Hoff factor will be 1, right? Okay, the actinoids generally show which oxidation state? Okay, this is gone, +3 oxidation state. Okay, I want you people to answer what is the highest oxidation state shown by the actinoids. Answer me in the comment section. Yes, fast. What is the highest oxidation state shown by the actinoids and which element, which actinide shows it? Answer me below here. Next, 18 is going to be para-hydroxyazobenzene. What is the color? Para-hydroxyazobenzene is orange. Okay, if you are having para-aminoazobenzene, the color is yellow. Okay, para-aminoazobenzene, the color is basically yellow. Okay, remember that. Okay, one more thing. Here I am telling you, this requires alkaline media. Question may come. Okay, this requires alkaline media and this requires acidic media. Okay, for the coupling reaction. Remember that. Information I am giving you here. Okay. Okay, someone is saying manganese. Okay, manganese कब से actinides में आने लगा यार? आप मेरा motivation खराब कर देते हो. Aha, actinides are which component? I want this answer. Please, go ahead with the answer. Tell me the answer. Okay, Navneet, very good. Neptunium as well as plutonium. Okay, it will show +7 oxidation state. Very good. Okay, so manganese wala, I can't read your name actually. Anyway, please clarify your answer. Okay, so in dash, the OH group is attached to the carbon is sp2 hybridized. So that's going to be orthocresol. Okay, so orthocresol, what is the structure? See, phenol with one CH3 is called cresol. Okay, now phenol with one CH3 is called cresol. So ortho position, so this is my orthocresol. Next, the carbohydrates which reduce Felling's solution and Tollens reagent are called as reducing sugar. Okay, let's go ahead. Okay, yes. Okay, tell me, the mixture which shows positive deviation of Raoult's law, AB interaction is weaker than that of individual AA and BB interaction. Yes, tell me the answer. The answer is going to be yes. Very good. It's C. Okay, I can see Navneet. Ma'am, अपने 7th question का answer. Okay, चलो देखते हैं 7th question में क्या है. 7th question, let's go back. Okay, 7th question का answer B होना चाहिए. 2-butanol. No, my dear. If it is aqueous KOH, तब आंसर जाके B होता. ठीक है? It is alcoholic KOH. Okay? It will undergo dehydrohalogenation. Remember that dehydrohalogenation. Okay? It will give you double bond. Said-Zev reaction. I mean Said-Zev rule. Okay? That's going to be this one. I mean option D, 2-butene. Okay? So it's not wrong. Yes, beta, Navneet, trust me, it's like that only. Okay, let's go ahead. Okay, let's go. A cell that converts energy of combustion of fuels like hydrogen and methane. Yes, give the answer. That's going to be fuel cell, right? Let's go ahead. The common name of the ethane dioic acid, that's going to be oxalic acid. Okay, Navneet is saying coordinate chemistry का ligands वाला issue ही पहले. Okay, that issue मैंने बाद में resolve कर लिया. That is initially I told oxalate, later on I corrected actually in the model paper video session itself I corrected कि CN minus होगा. ठीक है, चलो let's go, आगे जाते हैं. Write little bold. Let's go. Okay, the main natural source of acetic acid. Okay, question repeat हो गया. That is vinegar. Let's go ahead. Okay, pK value of phenol, orthocresol and orthonitrophenols are in this order. What is the correct order of acidity? Okay, so what is the relation of pKa and acidity? So if pKa is low, then acidity will be more. Okay, tell me the answer of this question. Tell me the answer of this question again. Okay, I can see distortion is giving answer D. Okay, Someone is saying A, someone is saying A, again D. Okay, so what you have to do? Just arrange them in the pKa order. So if I just go, what is the mode value? That is 10.2. 10.2, after that 10.0, then 7.2. So this will be your acidic order, right? So 7.2 is for orthonitrophenol, right? Orthonitrophenol. Okay, next if you see, so that is the most acidic. After that orthocresol, right? Sorry, after that phenol, okay, after that orthocresol. Okay, so that is the order of acidity. Okay, so yeah, your answer is going to be this one, option D. Okay, let's go ahead. Okay, a student took, ये बहुत important question, this is also very important question, okay. A student took 2 glasses of pure water from a water filter. He cools down glass A in a fridge and warms the other glass B on a stove. On comparing the solubility of oxygen H2O in glass A and glass B, he can state that where we are having more dissolved oxygen. Sorry. So if you increase temperature, solubility decreases, right? So for that case, you can just answer glass A contains more oxygen than glass B. Very good. Option A is the correct one. Very good. Okay, let's go ahead. Okay, for this question, I told you that whenever you will see decomposition of gas is going on, okay, and metal, what it calls, metal catalyst is given, metal surface is given as a catalyst, just close your eyes and mark it as a zero order reaction. So option D is going to be the correct one, right? Let's go ahead. Yes, there is no doubt, I guess. Okay, very good, very good. Okay, someone of you are saying this is option A. No, this is not option A, neither option B. That answer is going to be option D. Who are saying option B, please rectify that. It's not a first order reaction, it's a zero order reaction. Here they gave the hint. Whenever you will see any gas, it is decomposing in presence of a metal catalyst. Make sure you are marking it as a zero order reaction. So NH3 power 0. So power 0 means 1. It's going to be on option D. Okay. Let's go ahead. Let's go ahead. Okay, let's go. Okay, so for this case, it is also an important question, okay? Important one. Let's go ahead. Phosphodiester linkage, you can see in the nucleotides. So B. Glycosidic linkage you can see in the monosaccharides. Peptide linkage you can see in amino acids. So B, C, A. B, C, A. Option D is the correct one. Okay. I guess it's clear. Let's go ahead. Okay. When an alkene reacts with a component X in presence of CCl4, reddish brown color of the component X disappears to yield vicinal dihalide. Okay, the component X. So you have to start with some alkene, right? So something you are treating in presence of CCl4. CCl4 is a media. You are having something that has some brown coloration and that will give you some vicinal dihalide. Here let's say X, here let's say X. Okay, so now definitely I will be having this X compound here only, otherwise how the X will come, right? So definitely it's going to be X, X2, that gas. Now which gas has brown color? Bromine gas. Okay, so it's going to be Br2. Option C is going to be the correct one. Okay, so Deepak, can you please tell me which one you did not understand? Deepak, can you please tell me for which question you need the complete explanation? Let's go ahead. Okay, so potassium permanganate is a powerful oxidant. It's a very important question, my dear. This particular zone itself is very much important. Okay, from the D and F block. Okay, so for this case you can see potassium permanganate is a powerful oxidant. That is true, definitely. Next, KMnO4 oxidizes I minus to IO3 minus in acidic solution. So that's gonna be wrong. Let me tell you, my dear, KMnO4 plus, I'm writing only manganate, okay, that will be better. MnO4 minus plus I minus, it will give you I2 always in presence of H plus. Always remember that. It will give you I2, iodine, okay. But if you are having MnO4 minus plus I minus, but the medium is alkaline or neutral, okay, alkaline or neutral, it will give you IO3 minus, okay. So in the alkaline medium, I minus will be oxidized to IO3 minus, but in acidic medium, it will be oxidized to I2, okay. So statement 2 is false. Statement 1 is correct, statement 2 is incorrect. I guess it is okay. Okay, option D, very good. Navneet, very good. Okay, someone is asking for numerical. Beta, this session is not for the numerical. Numerical will come up tomorrow at 11. Okay, I will only come up with a live numerical session. 50 numericals we will do. From there, your section E will be sorted. Okay, let's go ahead. Okay, consider the given reaction RCONH2 plus Br2 plus NaOH, RNH2 plus Na2CO3 plus NaBr. Which reaction is this? This is basically Hofmann bromamide degradation, right? So for this particular case, just let me know what will be the formula of the amide. Just be assured here in the reactant in the product, look at the reactant and look at the product. Here the product is 1 carbon less than that of the reactant. So tell me the name of the, tell me which one is the correct answer. What is amide? Tell me the answer fast. Yes, Navneet, we will definitely go ahead with the separate section for the organic that will come up on Sunday morning. Okay, so 2 mark and 3 marker also you will get by today itself. Okay, integrated rate equation beta we will do tomorrow in the evening. Full physical and inorganic we will do. So there integrated rate equation and that related whatever the queries, everything will be cleared. Okay, so yeah, let's go. Okay, someone is saying option C, someone is saying option B, someone is saying option A. Okay, can you please tell me what is the correct answer? Check the number of carbon, check the number of hydrogen. Yes, go ahead. What is the correct answer? Okay, Jia is saying the correct answer is going to be option A. Ajay is saying it is C. A, B, C, everything I'm getting, everything. Okay, someone please give D as well. Okay, so if you start with CnH5, let's say, let's take an example. If I am doing it with C2, okay, let me do it like that. Count it and tell me, huh? CH3, CH2, okay, wait. 2 carbon I must have, right? So 2 carbon if I have, then I should go ahead with CH3, C double bond O, then NH2. Okay, what is the formula coming out of here? This is basically C2, right? C2, I'm having H5, H5NO, right? From here I'm coming, right? Okay, let's go ahead. From here, if you go to the amine, then it will form something like CH3, CH3, then NH2, right? So here I am having carbon, definitely 1, carbon I am having 1, okay, and here I am having hydrogen 5 and 1 nitrogen, okay. So now tell me, what is the formula? Yes, the PPT will be uploaded, definitely. Your answer is going to be option B basically, okay, 1 carbon less, you can see 1 carbon less system, okay. So let's go ahead. Yes, I guess it is clear to you people. Let's go. Always remember, Always remember this should be one carbon-less system. Okay. Next. Okay, for this question, what is inner orbital complex and outer orbital complex? Okay, so, hello. See, here, no question, I mean, no discussion about which school, Instagram ID, Facebook ID, no, my dear. Here, only you people, me, answer and doubts. That's it, okay? Please, I'm requesting you people, we are in a serious mood. If you want to do any joke, if you want to crack any joke, crack with me, I will respond. Okay, so yeah, so let's go ahead. MnCN6 and FeCN6. So FeF6, sorry. CN is basically a strong field ligand. So whenever you are just taking any strong field ligand. So for that particular case, basically you will be having that particular ligand will be utilizing the inner d orbital, n-1th d orbital of the metal. So that is the inner orbital complex. Okay. If you use a lighter ligand, means low, weak field ligand, okay, that case it will use the nth d orbital, okay, hence outer orbital complex. So first one is inner, next one is outer. Option A is the correct one. Very good, very good. Okay, let's go ahead. Okay, triiodomethane was used earlier as an antiseptic. The antiseptic properties are due to the liberation of iodine. Okay, let's go ahead. Okay, so 14, electronic configuration of a transition element X in +3 oxidation state is 3d5. Okay, so if you are having 3d5 configuration in +3, means add 3 more electron. If you add 3 more electron, where it will insert? So 2 electron will be inserted into 4s, so 4s2, and here you will get 3d6. Okay, 3d6, 4s2, so it's going to be 26, right? This is basically iron. Okay, so let's go ahead. Okay, acetylation of salicylic acid produces, it's a very important question, okay? I'm marking the very important question, make sure you are going through them. Okay, acetylation of salicylic acid produces a compound which has anti-inflammatory and antipyretic properties, so that's going to be aspirin. Okay, type the IUPAC name of aspirin in the comment section. I will see who will give the answer first. Type the IUPAC name of aspirin fast. Let's go ahead. Okay, this is the fill in the blanks. Fast. Okay, so in the fill in the blanks, let's go ahead with the problem. The sum of the mole fraction of all component in a binary solution is 1. Okay, Gabriel thalamide synthesis is used for the preparation of which one? Primary amine, right? For primary amine. Water soluble component of starch is basically amylose. Okay, insoluble part if you ask, insoluble part if you ask, then that is basically amylopectin. Okay, remember that. Oxidation state of nickel in nickel CO whole 4. Okay, for this case CO is a oxidation state of CO is 0. So nickel is also going to be 0 here. Okay, that is also gone. 2,4,6 trinitrophenol is commonly used as picric acid. Okay, I'm just writing PA. Okay, I can see the answer. No astalgia. Okay, 2-acetoxybenzoic acid. Very good. Pajju, it's not the correct answer. That is salicylaldehyde. That's not the correct answer. Okay, Marvin, 2-acetoxybenzoic acid. Very good. Okay, please, whenever I am taking any question in between like this, I just asked you, please focus on them. You need them. If you do the mistake right now, then please, this is the correct time to do the mistake, because once in the 11th hour you do the mistake, you will remember it. Okay, so yeah, let's go through the next one. Okay, so this one, cumin hydroperoxide on hydrolysis of dilute acid. So cumin to phenol synthesis, it's going to be super duper important. So that will give you phenol plus acetone, right? Let's go ahead. Okay, next, among the following cells, okay, which one is used as like in Apollo space station, that is H2O2 fuel cell, right? Let's go ahead. Okay, next question. Okay, for this question you have to proceed with the initial rate method, right? Initial rate method to find out. Okay, so let's go ahead. Okay, can you show the reaction? Definitely I can show you the reaction, my dear. Are you asking for the cumene phenol or that one? Aspirin, right? See. Wait. Okay, you have to do the reflux in presence of acetic anhydride. Okay, you have to do reflux. Okay, then you will end up with this thing. Okay, I guess this was the formula if I'm not wrong. Okay, this is a sort of the reaction. Let's go ahead. Okay, so here you can see we will go ahead with the this thing, I mean initial rate method. Okay, so yeah, let's go. First we will just find out the different equation we will write from here. Okay, sorry, let's go ahead. Okay, let's write the reaction at first. So rate we will write first. I am directly going to it. Okay, 6 into 10 power minus 3. 10 power minus 3 is basically K into 0.1 power X into 0.1 power Y. Okay, next 7.2 into 10 power minus 2. 10 power minus 2, that's going to give you K into 0.2 power X into 0.3 power Y, right? Next is 2.4. 2.4 into 10 power minus 2 is going to be K into 0.1 power X into 0.4 power Y. Okay, next 2.88 into 10 power minus 1 equals to K into 0.4 power X into 0.3 power Y. Fine. Now we will solve it for X and Y. So what is the trick for it? You have to check for the common terms gets eliminated. Okay. So here you can see. So for this case, if I take equation 2 and equation 4, then this 0.3 can be cancelled out. So let's take it. Okay, so 7.2 into 10 power minus 2 divided by 2 point, so what I'm doing, 4 divided by 2 into 2.88 into 10 power minus 1, right, is basically equals to K into 0.2 power X into 0.3 power Y divided by K into 0.4 power X into 0.3 power Y. So this gonna be cancelled out, right? And here I'm going to get, okay, I did it reverse. So 2 divided by 4, it would be better actually. Anyway, okay, chalo. 1 by 4 is basically 1 by 2 power X. So just take it reverse. Take it reverse. 4 equals to 2 power X. So X is going to be 2. Fine. So X value we got. Now I need the Y value, right? So I need the Y value. So let's do equation 3 divided by 1. Equation 3 divided by equation 1. Okay, so 3 is basically 2.4 into 10 power minus 2 divided by 6 into 10 power minus 3 is going to be k into 0.1 power x into 0.4 power y divided by k into 0.1 power x into 0.1 power y. So this will be cancelled out. Here you will get 4, here you will get 4 power y, hence I can get y equals to 1. So if I just assemble them together, a power 2, b power 1, a power 2, b power 1, option C is the correct one. Okay, I guess. Okay, Gia. Okay, so basically you have to write the equation. It's a very important problem, my dear. Write the equation first. Okay, this is my rate value. What is the rate law? R equals to k into a power x into b power y. In accordance to that, with the given datas, you will get 4 different equations. Put the rate value, put k normally, a concentration you put, b concentration you put, power x and y. Solve this for x and y and you will get it. Okay, I guess it is clear. Okay, explain again. Wait. Okay, see my dear. So basically, if there are sorts of datas, okay, let's say A value, concentration of B and R, these are given. Okay, let's say this is given as 0.1, this is 0.1, this is something 2 into 10 power minus 3. I'm random, I'm giving some data. This is 0.2, 0.3, let it be some 4 into 10 power minus 3, like that. Different datas are given. Okay, this is called initial rate method. Okay, so for this case, whatever the data, maybe 4 and 5 sets of datas will be there. Okay, so here you have to put your main equation, you write R equals to k into a power x, b power y. Okay, so from where I'm getting it? See, they gave the reaction, right? So, sorry, wait. Okay, it's gone actually. So let me write it once again. Okay, so let's say different data 0.2, 0.2, 2 into 10 power minus 3. Here let's say 0.1, 0.1 or 0.3, 4 into 10 power something minus 3. These are the datas. So write the main equation k into a power x, because this value you don't know, b power y, something like this. If you know this, you can write the rate equation. Now keep putting. Okay, so this particular thing, this is the value of R, that is 2 into 10 power minus 3, right? And then equals to k. First value you put, a value is given as 0.2 here, power x. B value is given here, 0.2 power y. Keep it your as equation number 1. Okay, make another equation for the second data. So here R value is given as 4 into 10 power minus 3, 10 power minus 3. Here k into a power, a is 0.1, second, okay, power x, here 0.3 power y. This is your equation number 2, right? Let's say one more data I am having. Okay, let's say this is my 0.2, this is my 0.1, this is my, let's say what I should 1 into 10 cube, like that. This is the value. Another value you write, 1 into 10 cube equals to k into 0.2 power x into 0.1 power y. Like that you make the equation first. Okay, now you have to find out the value of x and y, right? You have to find out x and y, right? So now what I can do is, see, if you divide equation 1 and equation 3, then this 0.2 will be cancelled out, and there is a chance you will get that y value, because y values are different. See, different value. So like that, one term you cancel out, like that you divide. Okay, so what I am going to do here, let's say 1 divided by 3. Okay, so it will be 2 into 10 power minus 3 divided by 1 into 10 power minus 3 equals to k into 0.2 power x into 0.2 power y divided by here k into 0.2 power x into 0.1 power y. So this, everything will be cancelled out, right? So from here you will get 2 equals to 0.2 divided by 0.1, that is going to be 2 power y, right? So from there, see, this is also 2 power 1, this is also 2 power y. Comparing both sides, you can write y equals to 1. So similarly, one more data if you give, I just gave random example, you can get the x value as well. Okay, just let me know if you understood this thing or not. Okay, let's go ahead. I guess you understood this. Let's go ahead. Power 3, no, this is minus 3. Mistakenly I gave minus 3 can be only cancelled out. Okay, so I guess this is clear. It's a random example actually I gave. Okay, so this is the initial rate method. Very easy, my dear. Don't miss marks here. It's a very important question. You can get this type of question in the clear. I mean in your question paper. Let's go ahead. Okay, I guess this thing is clear now. Let's go. Okay, so fill in the blanks. Let's do polyhalo compound used for the anesthetic. N is missing here. Anesthetic during the surgery. This is basically, we all know it is chloroform, but let me tell you something, my dear, nowadays they don't use chloroform. Nucleic acids are the long chain polymers of, tell me the answer here, nucleotide, right? Nucleotide. Next, Van 't Hoff factor for KCl. So KCl, whenever you will see ionic compounds are there, dissociate them. K plus Cl minus. Check how many ions you are getting. 2 ions you are getting, right? So your answer will be 2. The number of hydroxyl group present in the glycerol. So glycerol looks like this. I'm not writing the hydrogen. This is how the glycerol looks like, okay? So it's going to be 3. Okay, transition metals are known to make interstitial compound. Formation of interstitial compounds makes the transition metal more. This one, tell me, 20, you tell me if it is hard or soft. Okay, 20 is hard, very good. Okay, I guess this is clear. Let's go ahead. Yeah. Okay, so my dear student, we solved 45 MCQs, even more fill in the blanks if you consider. Okay, so here I am going to give you the booster. Okay, so one by one chapter wise we will go. Okay, 200 more we have to do. So yeah, let's get started. Okay, yeah, this is the first question. Statement 1, enantiomers are non-superimposable mirror images on each other. So that's going to be true, right? Okay, sorry. Anyway, let's go ahead. Okay, drink some water. Yeah, 100 quota will be done. Then I will be also drinking some water. You people also take a chill pill break. But break is only for 5 minutes. Okay, let's go ahead. Statement, enantiomers are non-superimposable mirror image on each other. That's going to be true definitely. Statement 2, a racemic mixture shows zero optical rotation. So both the statements are going to be correct, right? Because racemic mixture means equimolar mixture of both D and L isomers, right? Let's go. So D and L, what they do? They undergoes internal compensation, right? They cancel out the optical activity of each other. Let's go ahead. Okay. 4 haloalkane compounds represented by 4 haloalkane compounds represented by letters M, N, O and P having boiling point 24.2 degrees Celsius, 38 degrees Celsius, 3.56 and 101 degrees Celsius respectively. Okay, among the 4 compounds, N most likely to be. Okay, what is the N, you tell me? So N has the temperature 38 degrees Celsius. Okay, tell me the answer. So basically, if you just see, M will be having how much? 24.2. 24.2. N is basically how much? 38 degrees Celsius, right? 38. Another one is MnO. O is basically how much? 3.56. 3.56. P is basically 101.6. So this is the highest one. So highest one will be which one? The bigger size with something that is having more atomic mass. So this P must be D, this one, right? Next, if I go ahead further, if you see N is in between, like 38 degrees Celsius. After 24, 38 is the option. Okay, so in between if you check, that must be C2H5Br, right? C2H5Br. So option C is going to be the correct one here. Okay, just let me know if you understood this thing or not. Okay, so let's go. Okay, someone said it's option B. No, option B is not the correct. Option C is the correct one. Okay, C in between red data. Okay, just after 101, just after these, you have C2H5. C2H5. See, here carbon is 1, here carbon is 1, here carbon is 2. So more longer chain length, and you are having Br as well. So expectedly, it is having more boiling point. So just after 101, you will be having 38 degrees Celsius. Okay, let's go ahead. Okay, so homologous series of alkyl halides are represented by the general formula. Tell me which one? This is an easy one. So one hydrogen will be replaced by one halogen. Option A is the correct one. Usually what we write? Homologous alkane series, CnH2n plus 2. Right? One hydrogen you replace with one X. So 2n plus 1 X. That's it. Let's go ahead. Toluene reacts with halogen in the presence of iron chloride, giving ortho and para halo compound. The reaction is electrophilic substitution reaction. Okay? Electrophilic substitution reaction. Next, let's go ahead. Which reagent will you use for the following reaction? So this is basically, you can see it is nothing but the chlorination. Okay, it is nothing but the chlorination of the chlorination in alkane chain, right? So that you can do in presence of Cl2 and UV light. Okay, very good. Let's go ahead. Next, adding the following compound in the increasing order of their boiling point. So this is having bigger chain length, right? Having more surface area, hence more boiling point. After that, this lesser branched and this is more branched. So first will come B, then it will come which one? A, then it will come C. So option C is the correct one. Okay. So I want you people to give the answer a little fast as well, okay, so that I can also go fast with you people, okay. So yeah, let's go. Very good, Samruddhi. Okay, let's go ahead. Chlorobenzene is formed by the reaction of chlorine with benzene in the presence of AlCl3. This is L, huh? Which of the following species attacks the benzene ring in the reaction. So basically in presence of AlCl3 plus Cl2, they makes a complex, that is AlCl4 whole minus plus Cl plus. Okay, so you will get an electrophile, that is Cl plus. Okay, let's go ahead. Distortion, wrong answer. Cl minus will not be formed, Cl plus will be formed because it's an electrophilic substitution reaction. Okay, chlorine forms plus charge. Be careful about it. Let's go ahead. What is A for the following reaction? Okay, I want you people to answer this question. So for this particular case, if you see, for this case, if I get the ring, definitely carbocation generation will be there because this is nothing but the Markovnikov. Okay, HBr we use, here HCl is given, see alkene and hydrohalogenation, right? This is the Markovnikov reaction. So there is a tendency for the student to mark this thing. Let me show you. CH2, here I am getting a carbocation and here CH2, right? Here I will be having CH2, right? So this particular case, this carbocation will jump here and one hydrogen will be shifted here. Okay, why? In order to get some stability. Okay, so from there, so this is basically hydride shift. Okay, hydride shift. So because of the hydride shift, what will happen? The carbocation will jump here. So as a result of this, you will get the carbocation here. This will be CH2, right? Here it will be CH3. Okay, one hydrogen is here. So if chlorine wants to attack, then the Cl minus will attack here. Okay, so overall compound you will get something like this. Okay, CH, here you will get Cl, here CH2, here CH3. So option D is going to be the correct one. Okay, so don't go for option C, option D is the correct one. There will be a hydride shift. Okay, I guess this is clear. Let's go ahead. Okay, I can see distortion gave the correct answer. Okay, Jia, kindly rectify your glitch. Okay, let's go ahead. Okay, so the order of reactivity of the following alcohols with halogen acid. Okay, so for this question, tell me, see, look at this case. So in case you want to like go ahead with the SN1 reaction, it will follow carbocation intermediate, right? So you have to check where the carbocation will be formed clearly. Okay, so see, for this case it is a tertiary carbon here, right? So tertiary carbon means it can give you stable carbocation, right? So C will come first, after that B, that is 2 degree, this is 1 degree, so B is going to be the correct one. Okay, let's go ahead. Which of the following alcohols will yield the corresponding alkyl chloride on reaction with concentrated HCl at room temperature? Same type of question I just have done. So that is going to be option D. Okay, so this is nothing but the Lucas reagent test, my dear. This is nothing but the Lucas reagent. What we use? ZnCl2 in presence of HCl, right? So this is only the halogen acid. Okay, always remember Lucas reagent will follow SN1 mechanism. So that's the reason 3 degree alcohol will give the turbidity faster. Okay, let's go ahead. Okay, very good. Okay, for this question, look at that and tell me the answer. Okay, identify the compound Y. Okay, so first is diazonium chloride formation, next Cu2Cl2, this is the Sandmeyer's reaction. So this entire N2Cl minus will go off and you will get one Cl out of it. So A is the correct one. Any doubt if you are having? Options are not visible. For which one? Sorry, I can't zoom it. Let's go ahead. Okay, So for this case, which of the following, okay, I can see some of you are giving correct answer. Rishika, very good. Okay, so which of the following is halogen exchange reaction? First one, this is a Finkelstein, this is the hydrohalogenation, this is Lucas reagent, this is some photoelectric reaction, electrophilic substitution. Okay, halogen exchange reaction is basically the Finkelstein reaction, right? Halogen, one halogen will be replaced with iodine, right? So option A, it is the correct one. Okay, let's go 14A, very good, distortion. Let's go ahead. Okay, actually here I can't do anything. I don't have any option to show it rather than this. Okay, this is B, C, D and this is option A. Okay, I guess this is clear now. Okay, let's go ahead. Okay, so for this question, I want you people to give the answer again. Okay, adds the following compound in the increasing order of their density. So for which case you have to check, you will be having maximum density, right? So for this case, D equals to M by V. D equals to M by V. So D is directly proportional to mass, right? So you have to check in which case you are having maximum mass or atomic weight, sorry, molecular weight. Okay, so that will be having maximum density. See here, one chlorine, one bromine. One bromine means heavier, right? Here two chlorine, here single chlorine, here no chlorine, right? So D will be having the maximum. So D, C, then B, then A. So option A is going to be the correct one. Okay, let's go ahead. I guess this is clear to you. Let's go. Next, in which of the following molecules carbon atoms carbon atom marked with the asterisk in is asymmetric? Okay, so asymmetric means chiral carbon. So you have to look for the chiral carbon. Okay, so let me just do a little bit like this. Okay, you have to check for the chiral carbon. Okay, so here you can see all the carbons are having different element. This is also chiral, this also you can see chiral. Okay, this is also chiral, but here if you just look at this thing, two hydrogens are there, right? So this is not chiral, right? So option, which one is going to be the correct one? So option A, B and C. Option B is the correct one. Okay, very good Samriddhi, very good Rishika. Okay, let's go ahead. Here you can see which of the following alkyl halide will undergo SN1 reaction. Okay, so here you have to check, here what you have to check, here you have to check which one is the best living group, chlorine, fluorine, bromine, iodine, sorry, fluorine, chlorine, bromine, iodine, what is the best living group? So let me tell you my dear, iodine is very, like, it's a very good living group, okay, because it can't form a proper covalent bond with the carbon atom. Iodine is bigger in size, carbon is smaller, okay, so overlapping is not proper, so iodine is a better living group, so option D is the correct one. Clear? Let's go. Okay, very good. Next question you can see, what should be the correct IUPAC for diethyl bromomethane? Okay, so, okay, wait. For diethyl bromomethane. Okay, so if I want to do diethyl bromomethane, what is the structure? So basically, diethyl group, right? CH2, here if I do CH3, this is basically CH2, CAC, CH2, this is one ethyl group, this is another ethyl group, C2H5, okay? CH2 Br, okay? So that you can take it as the structure. This is CH, okay? So here you will be having, so this is your 1, this is your 2, this is your 3, another carbon 4, Okay, so this going to be 1 bromo 2 methyl 1 bromo 2 methyl butane, 1 bromo 2 methyl butane. Okay, this is going to be M. 1 bromo 2 methyl, wait, this is not the correct answer. I guess there are some glitch in the question. Okay, we can leave this thing, later on we will go for it. Anyway, let's go ahead. Okay, this thing, let's go. Wait, 1 bromo, wait, I have done the mistake in the structure itself. Let me draw it again. So if I just draw this, that's going to be pen. So okay, so this is my bromo, wait, this is my hydrogen, this is my ethyl group C2H5, here 1 methyl group, okay, C2H5. Okay, fine. So now if you want to name it, so from here 1 2, okay, this is my 3rd carbon, 4th 5th. Okay, in the 3rd carbon you are getting the bromine, so 3 bromo pentane. Okay, so option B is the correct one, 3 bromo pentane. I guess this is clear for you people, just let me know. Okay, so I guess this is clear now, the structure is okay. Okay, let's go ahead. Okay, the next one. So the reaction of toluene with chlorine in the presence of iron and in absence of light yields. Okay, so basically if you are having toluene, let's say I am having this thing CH3, okay, and I am having Cl2 and FeCl3. So what I will get? I will get Cl, and here I will as it is CH3. Okay, but if I do it in presence of light, means Cl2 in presence of H nu, means in presence of light if I do, then it will be side chain chlorination. Okay, means you will get CH2Cl here. Okay, so this is the iron and Cl2 mechanism, that is basically electrophilic substitution reaction. Okay, so option B is the correct one. Actually option this one you will get, and 3, this one also you will get. So you will get ortho plus para, right? So you will get ortho and para mixture. Okay, so this is the correct one. I guess this is clear to you people. Okay, let's go ahead. Chloromethane on treatment with excess ammonia yields mainly. Okay, so chloromethane, if I just start with the chloromethane, so CH3Cl, right, CH3Cl. If you treat this with excess ammonia, then you will end up with simply methane will be substituted with one NH2 group. So this is basically methanamine. Okay, so option C is the correct one. Okay, so I guess this is clear. Let's go ahead. Okay. Next question, molecules whose mirror image is non-superimposable over them are known as chiral. Okay, which of the following molecule is chiral in nature? Okay, just let me know the answer, which one is going to be the chiral one. Okay, so the first one, let me just take 2-bromobutane. So butane at first, let me draw, this is my butane. In the 2 position I am having one bromine, so it seems this is the chiral one. 1 methyl group, 1 ethyl group and 1 hydrogen. This is the chiral one. So option A is going to be the right one. This is a very important question. Okay, let's go ahead. Okay, so next, reaction of C6H5CH2Br with aqueous sodium hydroxide follows. Okay, let me just draw the structure at first. So C6H5 means I am having one benzene ring along with CH2Br. Okay, so here I am going to give aqueous KOH. So definitely the change is something nucleophilic substitution, right? So you will end up with CH2OH. Now nucleophilic substitution you studied either SN1 or SN2. Here SN2 is not possible because backside is not clear. Backside is hindered, and another reason is it is 1 degree carbon. Okay, better if you go through a carbocation intermediate, carbocation, if you make it as carbocation, then the carbocation will be resonance stabilized through benzene ring, right? So definitely it will follow the SN1 mechanism in order to give you stable carbocation. What is the carbocation you will get out of it? You will get CH2 plus benzylic carbocation, right? So SN1 is the correct option. Let's go ahead. Okay, next question here you can see. Okay, I can see one question, Madhu. Which of the following are used to convert RCHO into RCH2OH? Okay, aldehyde to alcohol. Yes, what do you think about it? Okay, you can use anything like lithium aluminium hydride or NaBH4, it will work out there. Okay, so let's go ahead. Yeah, answer is B only. Lithium aluminum hydride you can use out of it. Okay, so let's go ahead. This is the next question. Tell me the answer. That is, which of the carbon atoms present in the molecule in the given below are asymmetric? Asymmetric means chiral, right? So if you just look at the structure, then just a minute. Okay, so which of the following, which of the carbon atoms present in the molecule given below are asymmetric? Fine. So if you want to find out the asymmetric, that's wrong. This is asymmetric. C is also asymmetric. So B and C is going to be the asymmetric carbon. Okay, let's go. Next one. Okay, I guess the options are visible here. Okay, which of the following compound will give racemic mixture on nucleophilic substitution? See beta, racemic mixture means, racemic mixture they are asking. So definitely it has to follow the SN1 mechanism. It has to follow the SN1 mechanism, means it should proceed through carbocation intermediate. So you have to check where the carbocation will be stabilized. Okay, so here you can see, for first case it is basically 2 degree. Okay, for this case it is a 2 degree. It is a 2 degree carbocation you will get. This case I will get a 3 degree carbocation, so definitely this is going to be stable, right? Next, this particular case, if you just look at that, this is also an 1 degree one, right? 1 degree. So here also you will not see any stability. Right, here also you will not see any stability. So what is going to be the correct answer? So for this case, what will happen? Let me just give you one hint. So CH3, CH, here C2H5, right? C2H5. Further here, if carbocation comes, if carbocation comes, it will be shifted here through the hydrogen shifting. Okay, means further it will be shifted like this. CH3, here C, here carbocation, here hydrogen, here CH3. Wait, this hydrogen will not be here. Okay, here you will be having CH3 and here again C2H5. Okay, so now you can see initially it was 1 degree, but now it formed 3 degree carbocation, right? So in order to gain some more stability. So B also and C also. So option C is going to be the correct one. I guess this is clear. Let's go ahead. Okay, hydride shift, very good, Samriddhi. Okay. Yeah, distortion, basically chiral carbon, see this carbon always should be having with a single bond. Okay, but here you can see carbonyl group is there, C double bond O. Let me zoom it. See, carbon double bond is there. Okay, so double bond will not give you the asymmetric one. Okay, so let's go ahead. This double bond O will not give you the asymmetric one. Okay, Madhur, just let me know which one is not clear for you. Okay, let's go ahead. Okay, so here you can see this is the next question. Just okay, this is not clear, I guess. Just look at that. Okay, so what they are asking the question, in the question, arrange the compounds in the increasing order of rate of the reaction towards nucleophilic substitution. Okay, so you have to arrange them in the order of nucleophilic substitution. Okay, so let's go ahead. So check if you are having electron donating group or not. Let me tell you, my dear, electrophilic substitution, right? Sorry, nucleophilic substitution. Nucleophilic substitution means some electron enriched group, let's say Nu. Okay, some electron enriched group want to come here in the benzene ring. Now benzene ring itself is electron rich, right? So why it will take another electron rich system, right? So I have to look for the system where electron deficiency of benzene is little less. Okay, so definitely if electron withdrawing group is present that can takes out the electron cloud density of benzene ring, then benzene can accept nucleophile, right? So now here you can see I am having NO2 group, here also in the ortho position and here also in the para position. So now you have to check NO2 from the ortho or from the para, from where it can pulls the electron cloud nicely. Right, so basically let me tell you, sorry, this is meta position. So NO2, whenever it is in the ortho or para position, it can pulls the cloud nicely, right? In the ortho position, it can pulls the cloud nicely. So it will be maximum electrophilic to take the nucleophile. It will be maximum electronically poor system to takes up another nucleophile, because NO2 is taking away its electron. Okay, so B will be first, then C, then A. Okay, so your answer is going to be first B. Wait, which one is the answer? Your answer is going to be B, C, A, option C. Okay, I guess this is clear to you. Okay, I guess it is clear. Vaibhav, we are not gonna do the numerical today. For numerical, tomorrow morning 11 AM, 50 numerical, top numerical we will do. Okay, 5 marker, 2 plus 3 marker you will get by today itself. Okay, by today itself. Actually, I have a planning to do both numerical and all name reaction together tomorrow. Okay, so yeah, let's go ahead. Okay, for this question, okay, again let me zoom. Again same type of question, I want you people to answer this. In the question, arrange the compounds in the increasing order of the rate reaction towards nucleophilic substitution. So again you can see you are having only one NO2 here all the ortho and para, both the cases you will be having NO2. So I guess I don't have to tell you this, what is the correct answer for this case. So definitely for those cases, this is going to be the correct one. I mean not correct one, I mean maximum rate higher for this case, then this, then this. So C, B, A, right? Okay, so C, then B, then A. So option D is going to be the correct one. Let's go ahead. Okay, so here, so you can expect actually this type of question for the rate of the nucleophilic attack. Okay, so that's the reason I kept this type of problem. Okay, so let's go ahead. Okay, Samruddhi, very good. C, B, A. Okay, now Samruddhi said A, B, C. Sorry, it should be C, B, A. Okay. Okay, next question you can see in the questions, arrange the compound in the increasing order of the reaction towards nucleophilic substitution. Now you can see you are having CH3 group. So CH3 group is basically electron donating. CH3 group is basically electron donating. So better if you don't have electron donating group. If benzene already electronically enriched, further nucleophile will not come, right, if it is electronically reached. So electron withdrawing group was helping, but electron donating group will not help me, right? So A will come first, then B, then C, right? In the C you are having 2 CH3 group. So A, B, C. Okay, so first will come A, then B, then C. So option D is the correct one. I guess this is clear to you. Okay, let's go ahead. Yeah, options are not cleared, I understood, but once I'm just zooming it, you can just predict the answer, right? So that's it. So let's go ahead. Which is the correct order of boiling points of the following compounds? Okay, just I want you people to tell the answer first. Okay, so you can see what are the options. 1 iodobutane, 1 bromobutane, 1 chlorobutane and normal butane. Yes, which one should come first? Definitely if you are having iodine, heavier atomic weight, that will come first, that will be maximum. So iodobutane, okay. So I am writing IB, IB means iodobutane, okay. Next iodobutane will come first, then definitely bromobutane. Okay, I am writing bromobutane as BB, normal. Next, definitely chlorobutane, CB, right? Next, it will come as normal butane. Okay, so yes, option A is going to be the correct one. Okay, so boiling point related one question you can expect in the MCQ zone. Okay, let's go ahead. Okay, 29th question, which one? This one? Oh yeah, I marked wrongly. So let's change it. So what is the correct answer for this case? A will come first, then B, then C. Option C. It's just a marking mistake. Okay, now I guess it is clear. Okay, so you people are, you know, very badmash ho tum log. Why? Because whenever teacher makes mistake, you people become very happy. Okay, teacher is making the mistake. It's not our fault. So yes, let's go with the next problem. Okay, for this question, give me the answer first. Which is the correct increasing order of the boiling point of the following? So again, same type of question. I want you people to answer this thing at first. So you can see first we have 1 bromoethane, 1 bromopropane, 1 bromobutane. So definitely 1 bromobutane will come first. Bigger ring, I mean bigger chain as well as 1 bromine, right? So definitely, okay, benzene is also there. So bromobenzene, if you see, we have interaction, okay, hydrogen bonding type of interaction, okay, this type of things we will have. So bromobenzene will be having no maximum boiling point. So after bromobenzene, you may have the 1 what it calls butane, 1 bromobutane. Next you can have 1 bromopropane, next bromoethane. So what is the option? Bromobenzene, 1 bromobutane. Option D is the correct one. Okay, I guess it's clear. Okay, Are distortion, you don't have to tell. Sorry, I was just joking with you people. Okay, so okay, I can see someone is dancing here. Don't do this, my dear. Your exam will be dancing as well. Your paper will be dancing as well. Don't do this here. Okay, so yeah, let's go. Go ahead. So yeah, haloalkanes are done. We will go ahead. Haloalkanes, whatever we did till now, yes, whatever the MCQ, you will get common out of it. Let me tell you, yeah, it's common, and you will get definitely 20 out of 20. Whatever the question will come from haloalkanes, you can do it now. Okay, next, alcohols. Let's do the first one. So here we are having basically propene. So propane is allowed to react with HBr in presence of benzoyl peroxide. Arey, peroxide is there means anti-Markovnikov, right? Kharas effect. So in presence of the benzoyl peroxide and the product subsequently heated with aqueous KOH. Wow. So first we will do anti-Markovnikov mechanism, radical mechanism, then aqueous KOH. Aqueous KOH means it will undergo SN1, okay? SN1 or SN2 basically, nucleophilic substitution, okay? The final product obtained, let's do it. Okay, so first what we have to do, I'm not writing the hydrogen, so in case I try to write the hydrogen, sometimes what happens, carbon starts to cry. Why? Because I miss the valency in hurry. So I'm just writing the carbon here, okay? So this is the MCQ anyway. So HBr in peroxide, right? Peroxide. So in case I will get the bromine here and hydrogen here, right? Here I will get hydrogen and here bromine. Anti-Markovnikov, right? Next, what do you have to give? You have to give KOH. KOH, that too in aqueous media. So it will follow basically SN2 mechanism because 1 degree carbocation. Sorry, 1 degree carbon is there. Okay, it cannot form stable carbocation. So you will get C along with that OH. Okay, what is the name of the product? 1-propanol. Option C is going to be the correct one. This type of question, it's kind of tricky question, you can expect this. Okay, Gia, D is not the correct one. Okay, diol you will not get, it is normal substitution reaction. Okay, so let's go ahead. The ether on heating, it's a very important question, very important. Okay, ether on heating with concentrated HI. Okay, let's do. So I am having C6H5O, CH2, C6H5. Okay, let's go. So if I have this, okay, let me write it like that. This is benzene, oxygen, CH2, then another this. Okay, you have to think where the alcohol will be stabilized and where the iodide compound will be stabilized. Okay, so if I give HI here with the benzene itself, here itself the breakage will be there, and with the benzene I will get the alcohol, and here I will get the alkyl iodide, not alkyl, benzylic iodide. Okay, this thing. Okay, this plus this. So your answer is going to be, yes, option C. Okay, I guess this is clear to you. This is a very important question. Okay, option C is the correct, not A. Okay, because this position alcohol will be stabilized. Here the breakage will be there and oxygen will get one hydrogen. Okay, so yeah, let's go ahead. Okay, so options are visible. Let me show you. Okay, I guess now it is visible. Okay, so okay, in the following compounds, the order of acidity. Okay, so here you are having A, B, C, D. Tell me the order of acidity. Always remember, if you are having electron, sorry, you can't write like that. Electron donating group, if you are having, acidity will decrease. Electron withdrawing group, if you are having, acidity will increase. Okay. So for this case, nitro group is both the cases C and D, but nitro can have minus R effect maximum from the para position, ortho and para position. So D will be, this is definitely, nitro group is electron withdrawing, right? So definitely C and D, if you take C and D, one is meta, another one is para, right? So definitely option D is the maximum acidic. After that, definitely it's going to be C, right? After that it's going to be C. Thereafter, here you are having electron donating, so it will reduce acidity. So before that, D, C, then A, then B. Okay, so yeah, let's go ahead. So I'll be having this 4, 3, 4, 3, then 1, 4, 3, 1, 2, right? So option D is the correct one. Okay, is it clear to you people? Okay, let's go. Okay, very good, DCAB. Okay, so is it visible? Okay, the question is, in which of the following reaction phenol is not obtained? Phenol is not obtained, I guess. Okay, so this is the first case. See, check if the COH will stay there or not. Okay, so for the first case here, definitely carboxylation, decarboxylation will take place because this is the decarboxylating reagent, soda lime. Okay, for the second case, yes, you tell me, if H3O plus if you give, here you will get OH. Yes, here you will get phenol. More example if you want to see. Okay, so wait, sorry, what I said? Okay, sorry, if MgBr is there, H3O plus if you add here, you will not get phenol. Okay, you will get normal benzene ring out of it. Okay, so simple hydrolysis if you do, you will not get the phenol here. Okay, so be careful, here you will not phenol, but here you will not get phenol. So let's check the other option. N2Cl is there, H2O if you add, you will get phenol. Next you can see this one, NaOH is there, so definitely ONA you will get out of it. Okay, so this should be Cl. Wait, there is a mistake. This particular thing should be Cl. Okay, typing mistake is there, or option is wrong here. This particular thing is Cl. Okay, so your answer is going to be B. Okay, I guess it is clear. Okay, so Kalu Karma, I can see you. Please, if you really don't want to study, don't disturb the students. Okay, you can leave the session. No one is asking for you. Okay, no one is asking you to stay here. Okay, so please, it's my request. You can leave the session. Okay, it will not matter if I lose one student. Okay, I'll be having more students to listen to me. Okay, so don't create any mess here. Okay, let's go ahead. Okay, so next question here you can see, propene can be converted to propanol by oxidation. Which sets of reagent? That question I want. Okay, that question I want you people to answer. So I am having propene, right? Can be converted to 1-propanol. So you want the OH added here, OH to be added here. So C, single bond C, here you should add the OH. Okay, so here let me tell you one thing, my dear. In alkene, if you want to add the OH, you have two reagents. One is hydroboration oxidation, another one is oxymercuration demercuration. Okay, so here definitely you could understood what is the reagent, then definitely B is going to be the correct answer. But let me tell you why not oxymercuration demercuration. Oxymercuration demercuration, OM/DM if you would do, then here you will get the OH. Okay, in the intermediate carbon, but whenever you will do B2H6, okay, you will get it in the terminal carbon. Remember this. Okay, let's go ahead. Let's go ahead. Again, I don't want you people to discuss about it, and Kalu Akarma, whatever the name you are having, please leave the session, don't disturb the students. Okay, so let's go ahead. Okay, ma'am, according to you, I should study chapter wise or weightage wise? Please reply. Okay, so this particular thing I already have told you in the strategy video. See, if you are confident enough, study everything. Okay, if you are not confident enough, only by studying 6 chapters in accordance to blueprint, that can give you 63 marks. Okay, so what are those chapters? Solution, kinetics, because these are comparatively easy. Electrochemistry, I feel the student, they may feel that electrochemistry little hectic. Okay, so I will go ahead with solution, then kinetics. Fine. Next, what you can go through, in inorganic portion, you can go ahead with the coordination chemistry, because D and F block, there are so many trends you can mess up. But in the D and F block, you can go through the manufacture of K2Cr2O7 and KMNO4, must do. Okay, and coordination compound, you go ahead. Okay, inorganic, haloalkanes, haloarenes, alcohols and aldehyde ketones. These 3 chapters you do properly. Okay, you can confirm 63 mark. Okay, if you do it properly, definitely you have to answer all of them. Okay, next, in order to boost this, in order to get it 65 plus, go ahead with amines. Okay, so amines is a very small chapter, only fixed question you go ahead, like carbylamine reaction, Hoffman bromamide degradation. Okay, so this type of easy question, Gabriel phthalimide. Okay, go ahead with the amine, it can give you 65 plus. Okay, so yeah, these things you can follow, definitely you will get good marks. Okay, so what I said, I only said 7 chapter out of 10, even 6 can give you 63 plus. Okay, so yes, you can follow this thing. Okay, first, whatever feels easy to you, go ahead with this, but don't mess up. If you are doing physical chemistry, do it at once. Start with physical chemistry, go ahead with this, then numerical, then come to inorganic. Inorganic, whatever the confidence you are having, maybe D and F block and coordination, go ahead with the coordination, it's the scoring one. Okay, coordination you do. Okay, then next day you go for the organic chemistry. Okay, so yeah, let's go ahead. Okay, someone is asking if these questions are from question bank. Yes, question bank, they are from the question bank and previous year questions. Okay, I mixed and I kept it here. Okay, so let's go ahead. Okay, so here I guess the options are visible for you for this case. Okay, it's a very important question. Okay, it's a very important question. Okay, let's go ahead. Okay, so compound CH10O is found to react with NaOI, sodium hypoiodide, okay, and yields a yellow precipitate with characteristic smell. Okay, let me tell you, this is a haloform reaction. What I said? Haloform reaction. Better to say iodoform, because here I am using iodine. Okay, so iodoform reaction will give you yellow precipitation. Yellow precipitation of what? Sorry. Yellow precipitation of what? CHI3. CHI3. And you know what? When haloform reaction takes place, if you are having methyl ketone. So when you will get this? When you will have a methyl ketone. Okay. So now let me just make it easier for you people. So definitely this C8H10, by looking at the option also you can predict I must have a benzene ring. Okay, along with that one methyl ketone group, means this is for sure CH3CO, right? This is for sure, right? Now look for the methyl ketone unit. Alcohol will not give you the answer. Okay, but it can tautomerize to give you the alcohol. It can tautomerize to give you the alcohol, right? So for this particular case, if I just go ahead with the answer, your thing can be like this. Okay, this particular system, right? So now if it further tautomerize, it can give you this thing. Here CH, here you will get CH, here you will get OH, wait, this hydrogen extra. Okay, this will get OH, and here you will get one CH3. Okay, so your answer is going to be C. Okay, so I guess this is clear to you. Let's go ahead. Okay, so next one, next you can see the compound A on treatment with sodium gives B, and with PCl5 gives C. Gives C, B and C. Okay, gives B and C. C reacts together to give diethyl ether. So you have to find out A, B and C are in the order. So this is also an important question. Okay. This is also an important question. So yeah, let's give it a try. So let's just take from A, you are getting B, right, by treating this with sodium, right? Now on treating with PCl5 you are getting C. That's the thing. Okay, so definitely you have to start with some alcohol. Okay, then only it will react with both both Na and PCl5. So let's start with C2H5OH. Okay, so that will give you C2H5O minus Na plus. Okay, on being treated with PCl5 you will get C2H5Cl, right? Now you can see if B and C react, you will get diethyl ether. If these two react, no, this is basically Williamson ether synthesis. This is basically Williamson ether synthesis, right? This O minus will attack on this carbon and chlorine will leave the system. Hence, you will get this C2H5O, C2H5. Okay, this is a very important question. So your answer is going to be first alcohol, then ONA. Okay, your answer is basically D. Okay, I guess this is clear to you. Come on guys, give the answer. Okay, very good. Option D is the correct one. Very good. Let's go ahead. Okay, I guess this is clear to you. No. This is a very common reaction basically. Here you can see, this is the reaction, okay. So this is the cumin. Cumin will give you some A, okay, on being oxidized, okay. This is O2, there should be O2, okay. You will get A. On being hydrolyzed, you will get one phenol and one acetone. It is also an important question. So this A should be cumin hydroperoxide, right? So what is the formula of cumin hydroperoxide? Now check the option. This is option A, this is option B, this is option C, this is D, right? So definitely option C is going to be the correct one. Okay, option C is going to be the correct one. Okay, not A, my dear, it's not A, it's option C. Okay, that the carbon that is attached with benzene, that will be having the peroxide unit. Okay. Okay, very good. Okay, someone is telling it is option A. No, my dear, it's not option A, it's option C only. Okay, all name reaction one shot. Okay, all name reaction will come tomorrow again I'm telling you, in the live session when we will do the numerical live. That time, after the numerical problem gets over, I will start the name reaction. All name reaction at one go. Okay, you will get it. Let's go ahead. Okay, so the product of the following reaction. Okay, again you can see here B2H5 H2O2 means hydroboration oxidation. Just now what I told basically if you are having hydroboration oxidation, terminal alcohol you will get, terminal alcohol, right? So definitely there is no chance of having any double bond, so option B is going to be the correct one. Let's go ahead. Okay, distortion, I am not sure about it. You are also doing, I am also doing here. I am not sure I have done 100 or not. Okay, anyway, let's go. So let's go. Monochlorination of toluene in sunlight followed by hydrolysis with aqueous NaOH. Okay, tell me the answer. Okay, let me do it for you. Important question, okay. So this is basically CH3, okay. So then if you do the monochlorination, right, sunlight means Cl2 in presence of H nu. If you do, then you will end up with CH2Cl, right. Further if you treat this with aqueous NaOH, then here you will be having CH2OH. Okay, this is basically benzyl alcohol. Option D is going to be the correct one. Okay, I guess this is clear. Okay. Yeah, Gia, I will give you the break. Just a little bit, let me finish the target, then I will give you the break. Let me finish the alcohol. Okay, let's go ahead. Okay, how many alcohols with molecular formula C4H10O are chiral in nature? Okay, it's a nice question. So if I draw, C4 means it's a butane, right? So C, 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 C. So one OH will be there, right? One OH, let's add anywhere. Okay, so if you can add here, you can add here as well. So in my judgment, it coming one ethyl group, one methyl group, one hydrogen, one OH. So this is a chiral. Okay, so there is no other possibility to get it. If you take the OH here, same structure you will get. So only one possibility is there. Okay, let's go ahead. Okay, so what is the correct order of the reactivity of alcohol in the following reaction? Lucas reagent, right? Lucas reagent. So it will follow the SN1 mechanism. It will follow SN1 mechanism. So SN1 means 3 degree. 3 degree will react faster, then 2 degree, then 1 degree, right? So your correct answer is going to be option C. Okay, let's go ahead. Okay, very good, very good, very good. Okay, CH3CH2OH can be converted to CH3CHO. Okay, this answer, someone was asking this type of question. I want you people to answer 45. Please give me the answer. CH2OH to CHO. CH2OH you are having, from there you will be having CHO. Okay, so one thing let me tell you, my dear, did you notice that this particular thing, it's basically alcohol to aldehyde, right? Alcohol to aldehyde means it's an oxidation. Okay, so it's basically an oxidation. So definitely you have to use some oxidizing reagent. So catalytic hydrogenation, it is basically reducing agent. Reducing agent. This is also very good reducing agent. You have to do oxidation here. You have to do oxidation here, right? Pyridinium chlorochromate, that is PCC. It's a very good oxidizing agent. A little mild, right? And KMNO4, it's also an oxidizing agent, but strong. Okay, if you treat this with a strong oxidizing agent, it will be converted to directly carboxylic acid. Okay, in between aldehyde, if you want to go, then please go ahead with the chlorochromate, pyridinium chlorochromate. So your answer is going to be C, mild oxidizing agent. Okay, let's go ahead. Okay, okay, Sophie, very good. Option C is the correct one. Okay, so next, the process of converting alkyl halide into alcohols. Alkyl halide into alcohols. Okay, tell me the answer for this question. So you are having alkyl halide, you have to convert it. Sorry, alkyl, not aryl. Let's say you are having RCl, right? From here you have to take it as ROH. What is this? Don't you think that it's a substitution reaction, SN1 or SN2? Yes, option B is the correct one. Let's go ahead. Okay, this one. Which of the following compounds is aromatic alcohol? So what do you mean by aromatic alcohol? Where OH group is directly attached to the, just a minute. Why it's not zooming, I don't know. Okay, it's getting zoomed. While OH is added directly to the benzene ring. So here you can see option A. Here you can see after one carbon OH, it is not aromatic. But here also the same case, it is also not aromatic. Here again, this is the cresol, right? OH is added directly. So option A and D, right? Wait. So option A and D. So B is going to the correct. Okay. So yes, this one. Okay, I guess it is clear. Let's go ahead. Okay, let's go ahead. Okay, I want you people, see, I know you are also doing hard work here. I am also doing hard work with you people. You people will do, you will study up to late night. I will also be there in the live session till late night. Okay, so please, 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 I feel that I deserve at least one thumbs up. So please, if you have not liked the session, please like it. Okay, please like it. So I will get some motivation to do some hard work. Okay, so let's go. Let's go. Okay, so next question here you can see, give IUPAC name of the compound given below. Okay, so IUPAC name of the compound. Okay, I want you people to answer this. So from here I will start the numbering. I guess this is visible clearly. This is your compound. Okay, this is your compound. One more carbon is there. Okay, so I guess if I don't zoom it will be better. Okay, so let's go ahead. What is the IUPAC name? So we can name it, we can number it like 1, 2, 3, 4, 5, 6, right? So you can see I am having 5 chloro, how many carbon? Hexa, hexane 2 all, right? So your C is going to be the correct one. Okay, okay, 48C, very good. Okay, ma'am, you are clove without C. Clove without C. I didn't get you. Okay, okay, the section is good. Thank you so much. Please continue till end. But I'm feeling that I won't cover everything. Don't worry, you will cover everything. Today itself, once the session will be ended, it's a basically quick revision of all the chapter. Okay, so don't worry. The way I gave the strategy, follow that, you can cover everything. Okay. Okay, very good. Let's go. IUPAC name of metacresol. Metacresol. Metacresol is basically, this is OH. Here in the meta position, you are having CH3. Okay, tell me the name. Tell me the name of this compound. This is basically, if you are numbering it 1, 2, 3. So basically, sorry, 3-methyl phenol. Okay, A is the correct one. Let's go ahead. Okay, so IUPAC name of this compound, you can see this is an ether, right? So here this particular group you have to name at first, then this. Okay, so this particular group is methoxy group, right? This particular group is methoxy, and here if I number the chain 1, 2, 3. So in the 2 position you are having methoxy group. So 2-methoxy, 2-methyl. Here you can take methyl group as a branch. 2-methyl ethane. How many carbon? 1, 2, 3. Okay. So your answer is going to be, sorry, 2-methoxy propane you can take simply. 2-methoxy. Here you can take propane because 1, 2, 3. That's enough. Okay. Methyl group you can't take as a branch, so direct take it as a chain. Okay, I guess this is clear to you. Let's go ahead. Okay, 50, please. 50, someone please give the answer. Let's go ahead. Okay. 51. Which of the following species can act as strongest base? Okay, so in order to act as a strongest base, you must have electron rich system. Okay, electron rich system. See, OH minus is also having electron, OR minus is also having electron, this is also having electron. This is also having electron. But now you have to check in which case I am having maximum electron. See, the thing is, the magic here is OH minus small species. Electron I am having, but in order to be a very good base, you have to donate the electron. You have to donate the electron, right? So you have to check where the donating capacity is maximum. So base, when I am having electron donating group attached to it. See, here I am having C6H5. Resonance will be there. So oxygen electron, this lone pair will take part in the resonance. So it's not available for the donation in case of base. For this case, electron donating group, sorry, electron withdrawing group is there. So it will pull the electron from oxygen. So lone pair is not available, right? this case, R group, electron donating, right? Electron donating, it will push electron towards oxygen. So the lone pair will be available for the donation. So B is going to be the correct one. Okay, I guess this is clear. Hey you people, give answer. Why did you stop? Give answer. Fast, fast, fast. I want you people to participate actively. Fast. Let's go ahead. Okay, so which of the following compounds will react with sodium hydroxide solution in water? Okay, so this answer I want you people to answer. So sodium hydroxide is basically a base. Okay, so you need something that is a little bit acidic. Okay, that is a little bit acidic in nature. Okay, check which alcohol is more acidic or maximum acidic, because sodium hydroxide is a base. You need one acid in order to react. Okay, so C2H5, all of them you can see. Here I am having phenol. Phenol is the maximum acidic here. Rest of the cases you can see the conjugate base will not be stable, right? Conjugate base means acid after releasing its hydrogen, the negative it forms, the negative anion it forms, this is called conjugate base. The conjugate base must be stable, then acidity will be more. Okay, so phenol is going to be the correct option, because phenol conjugate base, that is a phenoxide, that will be resonance stabilized, hence it is a better acid. Okay, I guess this is clear, this is clear. Okay, let's go ahead. Very good. Let's go. Next, phenol is less acidic than. Okay, this answer. Phenol is less acidic. So check where I am having electron withdrawing group. So electron withdrawing group will reduce the acidity. So yes, it is orthonitrophenol. In the ortho position you are having nitro group, that is electron withdrawing, that will reduce the acidity. Okay, I mean sorry, that will increase the acidity. Okay, so let's go. Next one, which of the following is more acidic? Okay, this type of one question you can expect. Okay, so if you see benzyl alcohol, cyclohexanol, phenol, here chlorine is there, that is electron withdrawing group, right? Electron withdrawing is in nature. Electron withdrawing group means electron withdrawing group, if it is present, acidity increases, means option D is the correct one. Next, go ahead 54D. Very good, Madhu. Okay, next, this question, is it visible for you? Okay, so acidic strength order you have to find. Okay, okay, this is your compound A, this is your orthonitrophenol, this is your C, this is your D. Okay, one more is there, that is your E. Okay, okay, I'm blocking this guy actually because you are disturbing a lot actually. Okay, so let's go ahead. So if you keep disturbing like this, no, I also, you know, get distracted. Don't do this. Okay, so let's go ahead with the problem. Okay, so here you can see, first definitely acidity, definitely it is orthonitrophenol. Right? So if you are having nitro position here, I mean nitro group in the para, that's going to be first. So B will be first, after that it is in the meta position, right? So after B it should be D, okay? After that these are the electron donating. these are the electron donating group, OCH3. This is also electron donating group. Okay, so then we will write it at last. Okay, so B, D, then A. Okay, now in C and E, C should come fast because OCH3 acts properly from the para position, not from the meta. So at first C, then it will be E. So option B is going to be the correct one. Okay, I guess this is clear to you. Let's go ahead. Next, this question, I guess this is visible to you people. Mark the correct increasing order of reactivity of the following compound with HBr and HCl. Okay, let me write it down for you people. See, if you want to do the reactivity check with HBr or HCl, this is basically the substitution reaction. Okay, so first I am having this compound. I am writing this for you, CH2OH. Okay, so definitely it will not undergo any kind of SN2. Carbocation will be stabilized, so SN1 it will go through. Okay, so carbocation, if it forms CH2 plus, here you will be having the benzene ring for the first case. Second compound, if you see here CH2OH, here you are having the nitro group. So carbocation, if it generates CH2 plus, here you will be having NO2. Right, the last one is basically, this is basically CH2OH, here Cl. Okay, if carbocation comes, this is basically CH2 plus, this is basically Cl. Now see, here basically NO2 group, this is having minus R effect. Okay, Cl group, this is having minus I effect. So what you have to check? You have to check in which case the carbocation will be stabilized. So definitely this particular group, minus R cannot stabilize it. Okay, minus R cannot stabilize the carbocation. But for this case, A, B, C, if I name it, A, B, C, for this case, A will be more stabilized because nothing is there. Okay, after that C, then B. Okay, so A, C, first it will come A, then C, then B. So yes, option C is the correct one. Okay, let's go ahead. Okay, so I guess it is clear to you. Let's go ahead. Here you can see, arrange the following compound in increasing order of the boiling point. Okay, I guess we did this thing. No, we did with respect to bromine. Okay, tell me this answer. First one is propan 1-ol, butan 1-ol, butan 2-ol and pentan 1-ol. Okay, just tell me what is the answer. So definitely pentan, pent means 5 carbon system along with 1 alcohol. So that's going to be fast, then butan, okay, butan 1-ol, okay, then going to be butan 2-ol because it is a 2-degree alcohol in between, okay. Next, it's going to be propan 1-ol, okay. So which one is the correct answer? Option A is the correct one, okay. Let's go ahead. Okay, so we are going to start aldehyde ketones. So before starting the aldehyde ketones, take 5-minute breaks. I will also come back. I am here actually. I will take just water and I will come back. Okay. So you can also go and you can go and have water and come back. Okay. Okay, guys, whatever you are doing, is it the correct time to do this? What do you think? Is it a correct time to do this? Hurry, your exam is knocking the door and you people are just doing mess here. Don't do it. Okay. Okay, let's go with the aldehyde, ketones and carboxylic acid. Let's go ahead. Okay, so whoever was responding, please do it positively because we will go ahead. More questions are there. Yes, 100, more than 100 we did. Okay, 200 plus is our target. Yes, so let's go. Okay, so this is a hot question, okay, and this is also a very important question as well. Okay, very important question this one. Let's go ahead. Okay, an organic compound X gives a red precipitate, on heating with Fehling's reagent. Okay, which one of the following reaction yields X as a major product? Okay, so for this particular case, just a minute. Okay, so let's go ahead. On organic compound X gives a red precipitate on heating with Fehling's solution. Okay, so Fehling's solution, when it will give you a red precipitation, think about it. Whenever Fehling's will react with aldehyde. Okay, so whenever Fehling's will react with the aldehyde, it will give you the precipitation. So this X must be your aldehydic compound. Okay, now you have to check in which case you will get the aldehyde. So here I am starting with aldehyde. Definitely I will not get aldehyde here. Okay, here you are having Br. So Br, in case you are giving AgOH, it will replace the Br and OH will come. So here alcohol you will get. That is also not true. For this case here you will get ether. Okay, so that is also not true, right? So for this case here you can see this is oxymercuration, demercuration, right? So for oxymercuration, demercuration, if you undergo, and sorry, this is C2H2, ethine, right? Ethine, if you do oxymercuration, demercuration, then further it will undergo ketoenol tautomerism, right? That's what I just showed at the beginning, right? So it will give you the ethanol, okay, or acetaldehyde. It will give you acetaldehyde, okay. Let me show you once. It's a little tricky, but it's an important one, okay. So you are having this thing basically, hydrogen, hydrogen. Now you are giving this reagent, means H plus, 40% H plus, okay, and in presence of Hg plus, right? This is OMDM, okay. Now you will end up with C here OH, here H, like this, okay. Further it will undergo ketoenol tautomerism to get the, you will get acetaldehyde, okay. So option D is basically the correct one because you need one aldehyde, okay. Let's go ahead. Okay, I guess the reaction scheme is clear to you. First you are having benzene ring. In benzene you are giving Br2 FeBr3, electrophilic substitution. In that you give Mg in ether, okay. Then you give dry ice, okay. then you will get C. In C, you give nitrating reagent, that is concentrated HNO3 plus H2SO4. Let's do it. I will do it step by step. You will understand there. Okay, so I am having this benzene ring. Okay, I am giving Br2 Fe Br3, right? So I will get benzene with one Br. Okay, now here if I give Mg in ether, then I will get the Grignard reagent. So I will get something like this, benzene ring with MgBr. Okay, now I will give dry ice, means carbon dioxide, that will give me carboxylic acid, right? This is visible, yes, COOH, right? So this is my A, this is my B, this is my C. Okay, further D, if I want to write the D, so basically carboxylic acid, if it undergoes nitration, you will get meta-nitrobenzoic acid, okay, because carboxylic acid is basically a meta-directing group. Be careful about it. So option D is going to be the correct one. Option D is going to be the correct one. Okay, let's go ahead. Mic is not clear. Okay. Is it clear now? Just let me know. Okay, I guess it is clear now. Okay, let's go ahead. Let's go ahead. I guess you understood this thing. And this is an important question, okay? Mark it as an important one. Okay, next let's go ahead. Okay, it's again a very important question. Okay, so basically this group, the carbon that is attached with CN and OH both, okay, that is basically cyanohydrine. Option C is going to be the correct one. Next, let's go ahead. Okay, just tell me one thing, did you like the session? I'm doing a lot for you people, so please, please, please like the session. I don't have to tell you again and again. If you see my mehnat or hard work in your language, like the session, and if you have not subscribed, do subscribe. Yeah, what you are doing? Physics teacher, your Somik sir gave so many common question. You people did really well after having his suggestion, but still you did not subscribe. Now I am doing it. You are going to get the common question. Again, Jasmine ma'am will come, Ankit sir will come. They will also give common question. You will just take the advantage. You will write in the exam and you will forget us. So what's the benefit if you are not subscribing? So please, just a small subscribe. Do it. Okay, so yeah, let's go ahead. Okay, so thank you Distortion for liking the session. Thank you so much. Okay, so you can see a compound does not react with 2,4-dinitrophenylhydrazine. The compound is, so 2,4-dinitrophenylhydrazine. This particular compound will not react with any kind of alcohol. It reacts with carbonyl only. Okay, it reacts with only carbonyl to give you orange, yellowish orange colored dye. Okay, so you can see acetone is having carbonyl, acetaldehyde is also having carbonyl, this is also having carbonyl. Alcohol, it will not react. Okay, next go ahead. Okay, another important question, I am zooming it. You can see you are starting with ethine. Okay, then you are giving 1% HgSO4, H2SO4, OMDM. You are getting A. Again treat it with Grignard reagent, you are getting B, then do oxidation. Okay, I will do it step by step, you will understand. Okay, let's go ahead. If you are doing, it's a very important problem, okay, I did this type of thing, okay, so it can be a target zone. So C triple bond C ethine you are having. So if it undergoes OMDM, I already did this type of thing, you will end up with acetone, right? So that is basically, okay, let's not write the acetone, let's write the, what it calls, the alcohol itself, CH2, here you will get one hydrogen, and here let's say double bond, wait, here no hydrogen, here double bond, here C, here OH, here hydrogen. Further it will undergo tautomerism, then you will get the acetaldehyde, CH3, C double bond O, here hydrogen, right? This thing again and again I am telling you, this is your A, okay? This reaction remember properly, एकदम यहाँ पे घुसा लो, ठीक है? बहुत important चीज़ है, it's a very important thing, okay? Next step, you are giving CH3 MgBr, so CH3 MgBr. So CH3 is electronegative, that is a nucleophile, it will attack here, this will open up, okay? So you will end up with something like CH3, C, here another CH3, here O MgBr, right? OMgX, OMgX, and here you are having hydrogen, right? Further, if you do oxidation further or hydrolysis normally, this entire OMgBr will be converted to OH. So CH3, CH, CH3, here you are having OH, okay? So the end product, what is the end product? So this is basically isopropyl alcohol, yes or no? This is basically isopropyl alcohol. So your answer is basically B, okay? Let's go ahead. Just comment me if you understood this thing or not. Okay, let's go ahead. Okay, let's go ahead. Okay, the major product of the following reaction, very important question. It's an important question. Again, I'm telling you, from carboxylic aldehyde ketone chapter, whatever the question comes, they are super duper important, my dear. Okay, so let's go. So basically, this particular thing, let me show you one by one reaction, you know. So first, for this case, it will form COO minus NH4 plus, okay, COO minus NH4 plus, okay. Then it forms, if you heat, single time heating, you will get both amide, okay, you will get both amide, here COO NH2, here also COO NH2, okay. Further, if you heat, means strongly heating, you are heating strongly, right? If you heat strongly, then you will end up with, here 1 unit of ammonia will be released and you will end up with phthalimide. You will end up with phthalimide, means option C is going to be the correct one. It's a very important thing, huh? I guess it's clear. Yeah, just please answer me if you understood this, because it's an important question. Let's go ahead. You people stopped answering. It's very bad actually. Okay, I want you people to answer actually. Okay, let's go. What is the IUPAC name of the organic compound formed in the following chemical reaction? Okay, so Arey yaar, Varsha, what is this? I love you, Preetham. Love chemistry, bro. This is your chemistry examination. If you don't love chemistry, if you love something else, chemistry, तो उसका दिमाग खराब हो जाएगा भाई. It will not support you during the examination. So yes, this is not the correct time. Yeah, let's go ahead with chemistry. So let's go ahead. What is the IUPAC name of the organic compound formed in the following chemical reaction? Okay, so let's see. Skin is not visible. Screen is not visible. Can you please tell me if it is visible or not? Just let me know. Just comment if it is visible. Okay, let's go. So basically acetone you have to go ahead with C2H5 MgBr and dry ether. Okay, so if you are having acetone, CH3, CO, CH3. Okay, so now if you are giving C2H5 MgBr, okay, so C2H5 MgBr. So basically this C2H5 unit will attack here, this will open up, and as a result of this you will get something C here CH3, here C2H5, here CH3, and here OMgBr. Okay, now you do hydrolysis, right? H3O plus you give, H3O plus if you give, what you will get? CH3, here C, here you will get OH, here CH3, here C2H5. Let me break it, CH2, CH3. Okay, now I will number it so that you can understand. 1, 2, 3, 4. So 2 methyl propan 2-ol, sorry, butan 2-ol, 2 methyl butan 2-ol. Okay, I guess this is clear. Option D is the correct one. Very good. Okay, let's go ahead. Okay, this is you have to match. Okay, it's a very important question again. It's a very important question. You have to match the name reaction. Okay, so the first one you can see this is the Gattermann-Koch GK reaction. So with A, 2 will go, right? Next, this is the haloform reaction. Okay, so with B, 3 will go. Okay, next this is basically esterification, 4 will go. Next, this is basically what is going on, what is the product? So definitely nothing is there. So HBZ reaction, haloform reaction, sorry, this is basically alpha halocarboxylic acid formation, right? So you will end up with alpha halocarboxylic acid, that is HBZ reaction. Okay, so 2, 3, 4, 1. 2, 3, 4, 1. Option D is the correct one. Very good students. Okay, so let's go ahead. Okay, an organic compound X on treatment. Okay, this is an important question. Okay, an organic compound X on treatment with acidified K2Cr2O7 gives compound Y, which reacts with I2 and sodium carbonate to give you triiodomethane, the compound X. Okay, so let me tell you my dear, for this case, okay, so you people are doing XYZ here. Okay, so seriously, chemistry will betray you now. I swear, chemistry will betray you. Okay, so let's go ahead. So basically, if you react something with sodium carbonate in presence of iodine, it will form sodium carbonate, right? Na2CO3 plus I2. If you react this, you will end up with NaOI, that is sodium hypoiodite. This is the reagent. This is the reagent for the haloform test, iodoform test. Okay, so when this will react, if you are having methyl ketone unit, so from here definitely you can understand your X. Okay, an organic compound X on treatment with acidified K2Cr2O7, a compound Y. Y must be having the methyl keto unit. Okay, so now you have to find out the X formula, right? So in case you want to find out the X, definitely it is coming out from a this particular compound is having this type of group, CH3, right? Now you have to find out from where you will get it, from where you will get this type of thing. Okay, so K2Cr2O7 is a very strong oxidizing agent. Okay, so it can actually oxidize, 2-degree alcohol, it can oxidize 2-degree alcohol. So definitely it is coming out of this compound. Okay, CH3, CH, OH, CH3. Okay, so from this compound, if you treat this with K2Cr2O7, you will end up with this. Right? So your answer is basically D. Your compound X is D. This is the tricky one, remember. Okay, one HOTS you can expect in the MCQ zone itself. So 1 or 2 marker HOTS you can get. Okay, so where you will get the HOTS, that's not for sure. Okay, anywhere 2 marker, 3 marker, new medical, anywhere you can get the HOTS in the new medical, I mean in the MCQ as well. So be careful, you are preparing for this tricky question because MCQ has no options. You will not get like 20 MCQs are there, 15 you have to attempt. No, 15 out of 15 you have to do. So make sure you are practicing a little bit tricky one. It's an important question. I guess it's clear. Let's go ahead. You guys do cheat chat, avoid answering. Okay, very good. You guys avoid answering and do this cheat chat. Okay, that will give you the marks in chemistry examination. All the very best. Okay, yeah, let's go ahead. Whoever is listening, for them, yeah, please listen to this. Whatever this Pritham Versa love story is going on, please don't look at that. Don't get distorted. Distortion, don't get distorted. Okay, so yeah, go along with the flow so that you get the clarification. You want 20 out of 20, right? Sure shot. So please stay tuned here. Okay, so let's go ahead. So you are having here Z in the following reaction. Okay, so you are having one aldehyde. Okay, Pradyun is asking why not B? Last question. Why not B? B is an acetone beta. It's an acetone, but this particular thing is Y. This is definitely it is there, but this is Y, right? After being treated with K2Cr2O7, you have to end. This is a methyl ketone wala group. This is there. This is Y. From where the Y came? From here. This is your X, right? Pradyun, did you understand? Okay, so let's go ahead. Okay, so for this question, if you are having dilute alkaline KMnO4, so alkaline KMnO4 will completely oxidize this aldehyde, okay, and you will end up with carboxylic acid, cyclohexane carboxylic acid. Okay, so let's go ahead with the next question. Okay, addition of water to alkynes occurs in acidic medium in the presence of Hg2+. It's giving hints, okay. So basically it's happen only in oxymercuration, demercuration, okay. Next, ions as a catalyst. Which of the following products will be formed on addition of water to but1 ine under this condition? Okay, let's do it. So but1 ine, let's do. So this is your but triple bond C. Okay, so now in presence of acidic medium, H plus is there in Hg2+, right? So what you will get? You will get alcohol, OH, here double bond C. Now what it will do? It will do ketoenol tautomerism. Important question, okay? Ketoenol tautomerism to give you one ketone. Okay, double bond O, here C. Okay, so what is the answer? What is the answer? What is the answer? Option B is the correct answer. Okay, let's go. Next, which of the following compound is most reactive nucleophilic addition? Okay, definitely here one thing, this is also an important question, okay? Important question. So aldehyde and ketone, which one is more reactive? Aldehyde is more reactive than that of the ketone, right? Now you have to check for which aldehyde. Definitely this is not, this is gone. This is a ketone, this is also gone. Now which aldehyde? The aldehyde that is sterically not hindered. Okay, that is sterically not hindered, that you have to check. And where the carbon is more negative. Okay, sorry, carbon is more positive, that you have to check. Okay, so definitely it is possible in option A, right? Let's go ahead. Okay, let's go. 78C, no, it's not C. 78 is not C. You have to check for the nucleophilic addition, right? So if you see for this case it will come here, this will participate in resonance. Okay, so then you can see carbon is getting enough electron supply. So why further nucleophile will attack on carbon? It will not, na? Right? So definitely here carbon is getting enough electron supply. So that's not going to be the correct one. Okay, so yeah, let's go. I guess it's clear. Distortion, Madhu, Pradyun, let's go ahead. Okay, so next here you can see, next question. Okay, the correct order of increasing acidic strength. Okay, this is also a very important question. Electron, you must be having electron withdrawing group, right? Electron withdrawing group in order to give you the acidity. Okay, so what you are having? You are having acetic acid. Okay, let me just write it down. You are having phenol. If you are having phenol, ethanol, C2H5OH, you are having chloroacetic acid, right? So Cl, CH3, COOH, CH2, COOH, right? Chloroacetic acid and acetic acid, CH3, COOH. So you have to check for the most acidic one. So most acidic definitely is going to be acetic acid. Okay, most acidic is definitely going to be acetic acid. It is resonance stabilized, oxygen will be having negative charge, so yes, it is going to be maximum acidic. After acetic acid it can be chloroacidic, because you can see electron withdrawing group is there. Then you can go for these two. So definitely ethanol will come first, then phenol. So option A is going to be the correct one. Okay, let's go ahead. Okay, Pradyun is asking when the life station of 2 marker, 3 marker and 5 marker. 2 marker, 3 marker, 5 marker question I will give you in a video. Okay, actually I have planned subject wise in the sense physical and organic. Okay, sorry, physical and inorganic and organic. So yes, 2-3 marker question from the physical and inorganic, it will be there tomorrow. Okay, tomorrow evening, and day after tomorrow means Sunday we will be having organic 2-3 marker. Okay, so let's go ahead. Okay, wouldn't it be C? First is chloroacetic acid, then acetic acid. No, acetic acid is much more resonance stabilized. Okay, after that you can go ahead with chloroacetic acid. Okay, so yeah, let's go ahead. Wait. It is electron withdrawing group, no? Yeah, chloroacetic acid will go first. Sorry. Yeah, definitely the answer is going to be this one. Chloro, because it is having one extra electron withdrawing effect. After that acetic acid, then this thing. Okay, let's go ahead. Okay, for this case, for this compound can be prepared by the reaction. Okay, so this is benzophenol. No, it is not benzophenol. Let's go ahead. How you can prepare this? So this is an ester, right? This is an ester. So how I can get ester? I can get ester out of the reaction of alcohol plus acid, carboxylic acid. Okay, so let me give you, if you are having, let's say, alcohol. Okay, so alcohol, any alcohol you can take. What type of alcohol they have taken? It is phenol. Okay, okay, this you are having phenol. Okay, so phenol, if you are having any kind of acyl chloride unit, it is there, yes. If you are having any kind of acyl chloride unit, okay, let's say RCOCl, okay, and if you are having, let's say, pyridine in the medium, then you will end up with then you can end up with an ester. You can end up with an ester. Okay, so basically if you are having this type of thing, then along with that if I add this, okay, then what will happen, you know, hydrogen and chlorine will be eliminated from the system. HCl will go away and you will get that ester. Oxygen, C double bond O, then one benzene ring. Okay, so phenol and benzoyl chloride, right? So option B is going to be the correct one. Okay, I guess this is clear. Okay. I guess this is okay. Okay, anyone can give me the answer? You people don't do the cheat sheet and give the answer, please. Okay, so someone is asking a very valid question that why not A? Okay, phenol and benzoic acid in presence of NaOH, what it will form? If you have phenol in NaOH media, you need actually H plus over there. Okay, esterification reaction you are talking about, no? If you want to proceed with the esterification reaction, then what will happen? It needs catalytic amount of H plus, not in NaOH. Okay, so let's go ahead. Yeah. The reagent which does not react with both acetone and benzaldehyde. Acetone is a ketone and you are having benzaldehyde. Benzaldehyde means one aldehyde. So that is basically a very mild oxidizing agent you have to take. That is your Fehling solution. Okay. So it will react with benzaldehyde only but not with the acetone. It will not react with the ketone. Let's go. Cannizaro's reaction is not given by, you have to look for the alpha hydrogen. If alpha hydrogen is present, then Cannizaro will not take place, right? So for this case, see, for here there is no aldehyde, right? I mean no alpha hydrogen, so this will give Cannizaro. Next, for this also it will give Cannizaro, this will also give Cannizaro. Here I am having 3 alpha hydrogen, so this is the correct answer. Option D is the correct answer. Okay, this will not give Cannizaro reaction. Okay, let's go. Okay, so for this reaction, I guess the option is not clear to you. So these are the option. Okay, so the question is basically, which product is formed when the compound given is treated with concentrated aqueous KOH solution? This is the compound. Benzaldehyde, when it is treated with concentrated NaOH, it will undergo Cannizaro reaction. So Cannizaro reaction means you will get the benzoate anion and alcohol, right? Now look for the option. Sorry. So this is your first option. Definitely that's not going to be correct. These are the other options. Okay. So definitely option B is going to be the correct one. Okay, so let's go ahead. Okay, 83B, very good Madhu. Okay, so this is another important question, we already did it. You should give me the answer basically for this case. 84, here you will get the alcohol, right? Here you will end up with the alcohol. So what type of alcohol you will end up with? So again I am telling you, for this particular case the alcohol will be added in between. CH3C, here the alcohol will be added, here double bond, here CH2. Okay, so this is basically prop 1 in 2 all, right? So option D is going to be the correct one. I guess it is clear. Let's go ahead. 84D, very good Madhu. Okay, next. Okay, so I can see if you do 3 model paper, how many marks you can get? If you do model paper, you can get the passing marks hardly. Okay, that also I can't assure. Okay, because model paper is just to make you pass. That's it. 30 to 35 you will get common out of it, and that also I won't give you assurance. Okay, let's go. Okay, so this is the question. Sorry. This is the question, you can see. You are having benzaldehyde, you are treating this with CH3MgBr, then H2SO4, then hydroboration oxidation. Okay, let's do the reaction at first, step by step. It's an important question, okay? It's an important question. Okay, so let's do it. So first we will start with, okay, so the first we will start with CH3CHO, right? So CH3CHO, CH3CHO, right? Here I will be giving CH3MgBr, CH3MgBr. So CH3 will attack here, this will open up. So I will get something like, and H2O, let's do it, H2O together. Okay, CH3, here C, here I am having OH, here hydrogen, and here I am having CH3, right? So further, if I go ahead with the, you know, H2SO4, and if I give heat, it will undergo dehydration. Okay, so if dehydration takes place, I will get something like this, CH3, CH, double bond, CH2. That's it. Okay, next hydroboration oxidation. If I do hydroboration oxidation, then I will end up with, I am writing just simply HBO. Okay, that is basically CH3, CH2, CH2, here I am having OH. Okay, so yes, now what they are asking, this is your A, this is your C. They are asking compound A and C in the following reaction. What is the relation between them? They are positional isomer. See, the position of OH varies. That's it. Okay, I guess this is clear for you. Yeah, positional isomer. Very good. Okay, 85D optical. No, there is no chance of optical isomerism. Okay. So it's not identical, my dear. Here you can see OH is in the middle and here OH is at the terminal. Okay, so I guess it's clear. Let's go. Okay, so for this question, I guess this is visible. This is already zoomed. Okay, which is the most suitable reagent for the following conversion? Okay, let me tell you, for this case you are having methyl ketone unit. Again I came back with methyl ketone, sorry, methyl ketone unit. So methyl ketone unit means go for the halo form. It will end up with the carboxylate ion, means carboxylic acid you will get. So I2 and NaOH. Okay, let's go ahead. Okay, which of the following compound will give butanone? Okay, which of the following compound will give butanone on oxidation with alkaline KMnO4 solution? Okay, so butanone I need, means I have to start with alcohol. So definitely butanol I can start with. So C, 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 C. Here if I have OH, if I treat this with KMnO4, then I will end up with this. Okay, butanone. So butan 2-ol. Okay, because at the one position, means here if you have OH, you will not end up with ketone, you will end up with aldehyde, right? So let's go ahead. So what is the thing that you are getting? What is the model? That you must have 2-degree alcohol. 2-degree alcohol will give you the ketone. 1-degree alcohol will give you the aldehyde. Okay, let's go. And this thing is very easy. Clemmensen reduction, carbonyl compound is treated with zinc amalgam HCl. Okay, let's go ahead. Okay, so we are going to discuss the amines. Okay, let's go ahead. After doing the amines, I will just take a break, 5 minutes, small break. Then we will start the physical and inorganic. Okay, so I guess you people also realized that whatever the level of questions that we are doing, it's nothing but a quick revision. Okay, all the concept we are going through. Okay, so please take this session as a quick revision. Okay, so yes, that's going to be really helpful for you, because yes, you are not only solving the MCQ, your eyes are getting habituated with all type of problems and concepts as well. Okay, so whenever more type of question you will get, then you can relate, okay, this thing I did in MCQ as well. Okay. Okay, so yeah, we will do, definitely we will complete entire thing, my dear, entire thing. So as I told you in the strategy, please follow, because just today you finished physics examination, right? So 20 marks you prepared tonight, 20 marks is for the 1 marker, right? 20 marks you prepared by tonight. So doing MCQ is completely like, it will not pressurize your brain, right? So just with me you keep solving, okay? Your eyes should get habituated with the answers. That's it. Means whenever you will see the question paper, you must know from which concept I have to answer this. This much idea you must have, okay? So I guess this will be done. Okay, don't worry. Means so many questions, not so many, but whatever the question I kept here, that will clarify your concept as well. Not only the answers, your concept will be clarified. Okay, so let's go ahead. Okay, demotivated. Physics trauma, you forget, my dear, you gave it, you can't change anything, right? So being demotivated, don't ruin your upcoming examination. And this chemistry examination is going to be really easy. Take a chill pill and yes, solve the MCQ. From tomorrow itself, start preparing for the 2-3 marker. Okay, so let's go. Okay, again one more question, compulsory and optional. I already told you 6 chapter can give you 63. Quickly let me tell: solution, chemical kinetics, coordination, haloalkanes, alcohols, aldehyde. This 6 chapter can give you 63 plus only and only if you have covered completely. Okay, in order to boost it up, you can go ahead with amines. It will give you 65 plus. So biomolecules, D and F block, definitely being a teacher, I can't tell you leave this. Okay, but yes, compulsory, I told you. Okay. Let's go. Okay, this is a hot question and important question. This is a hot plus important question. Okay, basic nature of amine, that trend is different in the gaseous phase and in the aqueous phase. Aqueous phase, always remember, 2 degree amine will come first, then normal 1 degree amine, then normal ammonia. Then it comes up with the aryl compound, means with a benzene ring. Okay, so option C is going to be the correct one. Okay, why this? Because it interacts with the hydrogen of water. Okay, let's go ahead. Next, identify the product in the following reaction scheme. Okay, so let's do it. This is your benzene ring, you are having NH2, right? Now if you give AC2O, AC2 means acetic anhydride, okay? It will give you NHCOCH3, NHCOCH3, okay? Next, if you give Br2CCl4, then bromination will take place. Now what is the thing you know here? If you do bromination in only aniline, okay, it will give you ortho and para mixture, okay. But if you are doing the bromination in presence of this group, okay, then ortho bromination will not take place because of the steric hindrance. Only para, 100% pure para you will get, okay. So I will end up with this. Here I am having NHCOCH3, here I am having Br, right, in the para position. Further, if you give water, this entire group will remove and you will get back your aniline. Okay, here NH2, here you will be having Br. Okay, so para bromo, what? Para bromo aniline. Okay, so you will end up with para bromo aniline. Okay, it is a very important question. Okay, let's go ahead. Just let me know if you understood this thing or not, because it's an important one. Okay, let's go ahead. Okay, so next question is, okay, you are having aniline, here you are giving NaNO2, that will give you the benzene diazonium chloride. In benzene diazonium chloride, if you give HBF4, that will, you will end up with the what? Fluorobenzene, right? So benzene diazonium chloride and fluorobenzene. Option D is the correct one. Let's go ahead, let's go ahead, let's go ahead. Okay, someone is asking how come para? Okay, so how come para, my dear, because once you are adding Ac2O, acetic anhydride, okay, a big group is coming here, NHCOCH3, right? So now here if you give Br2CCl4, then Br will not get substituted in the ortho position in order to avoid the steric hindrance. So that's why if ortho is blocked, then it will go to para, na? So that's the reason you will get the para. Okay, so yeah, let's go. Okay, for this question, this is an easy one. Tell me the answer. So you are having N2 gas is liberated when HCl and NaNO2 react with the following compound. Okay, let's do it. So for this case, for first case, this will also give you N2 gas, urea will also give you N2 gas, amide will also give you N2, and the final one also it will end up with alcohol and will give you the N2. So all of them will give you N2. Okay, so this is also an important question. Okay, it's also an important one. Let's go ahead. Okay, so for this case, I guess the reaction is visible to you people. Okay, pH N2Cl means this is the that reagent, what it calls, not reagent, benzene diazonium chloride. If you give CuCN, you will end up with benzene with Cn. There lithium aluminium hydride, do the reduction in Cn, so CH2NH2 you will get. Okay, so benzene with CH2NH2 along with HNO2 will give you benzyl alcohol. Let me do this. Okay, it's a very important question. Okay, it's an important one, be careful. Okay, so I am having benzene N2 plus Cl minus. Okay, here I am giving CuCN in presence of KCN. Okay, that will give you benzene with Cn. Okay, now in this case you have to give lithium aluminium hydride. It is a reducing agent. Okay, lithium aluminium hydride will make this thing CH2NH2, right? Further, if you treat this with nitrous acid HNO2, you will end up with alcohol CH2OH. Okay, so this is basically benzyl alcohol. It's an important one, again I am telling you. Okay, I guess you understood this. Okay, 93 answer C, very good. Okay, explain 92. Okay, explain 92, basically NH2 if you treat this with HCl and NaNO2, okay, for this case you just think about the product, na. Definitely N2 will be released, nitrogen gas N2, see here HNO2 you will get, that is the diazonium chloride it forms, na. From there as a byproduct nitrogen gas is released. Okay, so from all of them it will be the same thing. Okay, so that's the thing. Let's go ahead. Okay, so nitration of aniline in strong acidic media also gives meta-nitroaniline. Okay, meta-nitroaniline, because, okay, just tell me, it's a big problem. Okay, nitration of aniline in strong acidic media gives meta-nitroaniline, because in spite of substituents, nitro group always go only meta position, no. In electrophilic substitution reaction, amine group is meta-directive, no ortho-para-directing. Next, in absence of substituent, nitro group always goes to meta position, that is also no. In acidic media, aniline presents at, this is the correct one. In the acidic media, aniline present in anilinium ion. Yes, anilinium ion, that's the reason meta-nitroaniline it will form. Okay, so this is clear. Because of the formation of the anilinium ion only, it will go to the meta position, because anilinium ion is meta directing. Okay, that's why it will take the nitro group in the meta position only. Okay, so I guess it's clear, a little tricky and difficult one as well. Okay, let's go ahead. The correct order of the basic strength. Okay, in the aqueous solution, I guess you can answer this now. 2 degree will come first, only one option related to this. Okay, 2 degree will come first in aqueous always. Okay, so yeah, let's go ahead. Which one which one I have to explain? 93. This one. Okay, so this is basically benzene diazonium chloride. See, pH N2Cl minus, right? N2 plus Cl minus, that is benzene diazonium chloride. Treat this with CuC and KCN, this entire N2Cl will go, Cn will come. Okay, now here you give lithium aluminum hydride, that is a reducing agent, strong reducing agent. In presence of this carbon is hydrogenate, carbon will be reduced. Carbon, if it is reduced, it will come up with hydrogen. Nitrogen, if it is also reduced, hydrogen will come. Here what is the situation? Carbon, nitrogen, triple bond. So triple bond will be reduced with hydrogen. That's it. So CH2, NH2. So now here if you give HNO2, then this NH2 will be changed to OH. Okay. Benzylic, this is a benzylic position, right? Benzylic position. Benzylic position, if you give HNO2, you will end up with CH2OH and nitrogen gas and all. Okay. I guess it's clear. Be careful, huh? Direct aniline. Let me just tell you one thing, my dear. Direct aniline means NH2 is directly attached to benzene ring. NH2 is directly attached to benzene ring. Here if you give HNO2, then this is diazonium chloride. Then it will form N2 plus. It will form N2 plus and Cl minus. But if you are having benzene 1CH2, then NH2, it is not directly attached. Then you will end up with benzylic alcohol. CH2OH. It's an important thing, huh? Remember this. Okay, I guess this is clear. Let's go ahead. Okay, did you like the session? Whoever, I can see some new people are joining. So yeah, please, if you are joining, I am here live, I'm standing here, I'm solving the question since 5. Okay, so yes, if you can see my hard work, like the session. Yes, just a thumbs up and subscribe. Okay, nitration of aniline is strong acidic medium also. Oh, okay, this already I told that you are asking me to explain. Okay, so okay, let me tell you, in acidic media what it does, if you are having aniline, right, if you are having aniline, aniline is a base, right, aniline is a base. In acidic media if you go, then it will form NH3 plus, means it will take one H plus. Okay, that is the role of a base, it will take up H, hydrogen, proton, it will form NH3 plus. Now if nitration wants to take place, if NO2 group wants to enter, it will check where it can enter. Okay, now NH3 plus, this is basically meta directing. Okay, why it is meta directing? Let me tell you, nitro group, whenever nitro group wants to enter, okay, it's an electrophilic substitution. So where the electrophile gets attached, where it will see that I am having electron deficiency more, I mean electron rich system. So basically in NH3 plus, if you go for the resonance, you will see in the meta position you will be having the electron density, the negative side. Okay, that's the reason if nitro wants to come, it enters, it chooses the meta position than that of the ortho and para. That's it. That's the reason ortho para directing, meta directing, from where the concept comes, where the charge density is maximum. For this case, it is in the meta position. Okay, I guess you understood. Please let me know if you understood this thing or not. Yes, please let me know. Please let me know if you understood this or not. Okay, you did not understand. Just let me know here, yes or no. I will come back. I guess this thing is clear. 2 degree will come first. Next, okay, this is also an important question. You can see. This is the reaction. NH2, if you give NaNO2 HCl. Okay, very good. Okay, HCl, then N2 plus Cl minus will come. Then some reagent you have to give so that this N2 plus gets removed. Okay, now tell me the reagent. Tell me the reagent to remove the N2 plus Cl minus. I'm looking for your answer. I will not tell this. (96B), very good, ethanol. If you treat this thing with ethanol, then it N2 plus Cl minus will go off. Very good, very good. Okay, Madhu. M. Markandia. Okay, inorganic, yes, inorganic, we will come up. Don't get excited, we will come up. Okay, 96D, no, D is not the correct one. Distortion. Okay, let's go ahead. Let's go ahead. Okay, this question, this is also you have to tell. I already told this thing. I already told. CN, at first you have to give lithium aluminium hydride, reduce it, CH2NH2. Then what you have to give? NaNO2 HCl. NaNO2 HCl togetherly will give you HNO2. Means HNO2 if you give in a CH2NH2, it will form benzylic alcohol, right? Now tell me the option here. Here you are going to get option B. Right? This is the same thing we did. Okay, Darshan, very good. Let's go, let's go. Okay, coupling of benzene diazonium chloride. Okay, this is a very important question. Again, I am telling you, this is a very important question. Okay, GI is saying our answer is A. No, beta, it's not A. Let me do the reaction for you again. Okay, because this is an important problem. I am having CN, right? If I am giving lithium aluminium hydride, okay, so I will end up with benzene CH2 NH2. Okay, then I have to give NaNO2 plus HCl. Togetherly they will make HNO2. Okay, so it will give me CH2OH. Okay, just now we did this reaction. Okay, so answer is going to be B, my dear. Okay, not A. Chlorine from where chlorine you will get? No chlorine. Let's go ahead. Coupling of benzene diazonium chloride with phenol occurs in dash media, with aniline occurs dash media. Okay, with phenol, that is para hydroxyazobenzene, that needs basic media, and with aniline it needs acidic media. Okay, so option A is the correct one. Okay, let's go ahead. Okay, which of the following is a 3-degree amine? Okay, that only you tell me. Which of the following is a 3-degree amine? So yeah, let's check. Triethylamine only, right? So with N you are having C2H5, and another one C2H5. That's it. So option B is the correct one. I guess this is clear. Let's go, let's go, let's go. Next, the correct IUPAC name. IUPAC name you try for this case. So basically with nitrogen you are having one methyl group, right? And this group you name 1, 2, 3, right? So N-methyl prop 2 in 1 amine. Okay, what is the correct one? Option D. Okay, let's go ahead. Okay, so amongst the following, the strongest base in aqueous media. Strongest base in aqueous media, again the same type of question. See, 2 degree will come first, right? That's what I told you. Okay, 2 degree will come first, then 1 degree, right? Let's go ahead. Okay, for this case, I'm zooming it a little bit. The question is, which one of the following is weakest Bronsted base? Bronsted base means, what is Bronsted base? Bronsted acid base, good donor of proton, right? Proton donor, good proton donor. Bronsted base means who can accept proton. Okay, so you have to check who is a good proton acceptor. I gave the hint earlier for this type of question. Okay, so just see, here you are having aniline, this is a cyclohexane with NH2, and this is something a heterocyclic compound with nitrogen. So you have to check where nitrogen can takes up the hydrogen. So for this case, that's the reason whenever you are about to do the nitration, first anilinium ion was forming, means it will form NH3 plus, NH3 plus along with the benzene ring at first. Okay, so I guess this is clear to you. Let's go ahead. Okay, 102A. Very good, Madhu. Okay, let's go ahead. Next here you can say, I guess this thing is clear to you. Okay, so you are having one amine, not amine, benzyl amine basically, and you are having one RX. Okay, which of the following alkyl halide is best suited for this reaction through SN1 mechanism? Very nice question. Okay, which one is best suited halide for SN1 reaction, right? So SN1 reaction requires what? Requires carbocation. You have to check among the following option which one can form stable carbocation. So I can see option C can form the best carbocation because C6H5 along with CH2 plus benzyl carbocation is resonance stabilized. This stability nowhere is there, right? So in order to perform SN1 reaction, I need best carbocation, hence C is going to be the correct one. Okay, is it clear? Okay, very good, Manoj. Okay, let's go. Okay, this question, which of the following reagents would not be a good choice? Okay, aryl nitro compound to an amyl. Okay, tell me the answer. So what I have to do? NO2 to amine. I need to do this conversion. What is the reagent? Okay, it is not a good choice. You have to think which one will not suit for this reaction. Okay, so let me tell you, lithium aluminium hydride in ether is not a good choice. It will reduce the complete system. Okay, so it's not the good choice. Let's go ahead. Next, because here you can see selective reduction you need, and lithium aluminium hydride is a very, strong reducing agent. Okay, so nitro group, only in order to reduce the nitro group, you can be selective a little bit. You can use hydrogen, you can use Fe in HCl, okay, this type of thing. Let's go ahead. Next question. Okay, so in order to prepare 1 degree amine from alkyl halide with simultaneous addition of one CH2 group in carbon chain, the reagent used as a source. Okay, tell me this thing. In order to prepare 1 degree amine from alkyl halide, let's say you are having one alkyl halide RCl. From here you want to prepare 1 degree amine RNH2, right, with simultaneous addition of one CH2 group, means you need to add something like this, RCH2NH2, RCH2NH2, step up reaction, one more carbon you have to add, the reagent that you have to use here. Okay, check where I am having one carbon extra. Check where I am having one carbon extra, because one extra carbon will come from the reagent only, right? Here, no extra carbon, no extra carbon. Here, see, one cyanide, one extra carbon. So that's gonna be the correct answer. Okay, let's go. let's go ahead. Okay. So the source of nitrogen in Gabriel thalamide synthesis, that I don't have to tell you, that is the thalamide itself. Okay, so let's go for some selective question. Wait. Okay, this thing you tell me. Hofmann bromamide degradation reaction is shown by. So Hofmann bromamide degradation reaction is shown by which compound? Definitely some amide. Okay, so this is basically option B. Okay, am I going fast? If you want me to be slow here. Okay, so KCN used to increase the number of carbon. Yes, absolutely. Okay, so I guess this is clear, my dear. Okay, amide, there was no amide, my dear. Let me check once. This is something we did, right? Where amide you saw? Not this, right? We are doing this. Sodium amide is not C double bond O. See, this is the formula of sodamide, Na with NH2, sodamide we call this. Okay, there is no C, no carbon. Okay, I guess this is clear. Okay, so the speed is fine, right? So let's go. So some selective question, let's proceed through. I guess this is okay. Okay, this type of problem I want you to solve more actually, because this is an important one. Okay, the increasing order of the basic strength of the following. Okay, tell me this one. Increasing order of the basic strength. Okay, if you are having basically an electron donating group will increase the basic strength. Electron donating group will make it more basic. So here CH3, it's an electron donating, so this should be more basic, and this is electron withdrawing, so it should be less basic. In between this will come. Okay, so what will be the answer? Okay, so the answer is basically 3, then 1, then 2. So option D is the correct one. Let's go ahead. Okay, next, this is also an important question. Methylamine reacts with HNO2. See, you people are very much habituated to see aniline. Aniline react with HNO2 to give you diazonium chloride. But if I am having CH3NH2, it's not aryl amine, right? It's a alkyl compound, alkyl amine. Okay, if you are giving NaNO2 plus HCl here, okay, this will form alcohol, my dear. Okay, this will form alcohol. Okay, so your answer is going to be C. Remember this, it's an important one. Okay, so yeah, let's go ahead. Okay, so let's go ahead a little bit. Okay, let me just check the question. This one. Okay, reduction of aromatic nitro compound using Fe and HCl. Same type of question we just did. Tell me the answer. Tell me the answer. Same type of question. So I am having nitro group. I told you I need a mild reducing agent. I can't use lithium aluminium hydride. So what I can use? So here I can use basically Fe and HCl, right? So Fe and HCl to give you the amine, right? NH2. Okay. So what you will end up with? Aromatic primary amine. Okay. Let's go ahead. Okay. I can see the question. Can Hofmann degradation used for the secondary? No, it cannot be used for the secondary or tertiary, primary amine. Okay, all the reaction that you studied, carbyramine, Gabriel thalamide and Hofmann bromamide. Okay, all of them that is for 1 degree amine. Okay, let me finish the amine, then I will take a break. Okay, so yeah, let's go ahead. One more question. Few more questions are there actually. We will go ahead. This thing you tell, it's a easy one. See, the reaction is named as, okay, it's a very important question actually. N2Cl, CuCl you have to treat, you will end up with ArCl, N2 plus CuCl. What is the name of the reaction? I want to see you people to mark it as a Sandmeyer's reaction. Okay, this is a common mistake that you people do. Okay, it's an important reaction, it's an important, I'm telling you. Okay, let me tell you. It's a Gattermann reaction. Okay, very good. Ajay, Vaishu, whatever the name you are having, I don't know if I pronounced properly or not. This is Gattermann reaction. Different reaction, Gattermann Koch, and this is only Gattermann reaction. This is not Sandmeyer. In Sandmeyer reaction, how will you understand? In Sandmeyer reaction, copper should be in +1 oxidation state. Here it is in 0 oxidation state. Right? Copper metal. So it is a Gattermann reaction. Okay? Always remember, carbylamine, there is no chance because carbylamine you have to end with NC. Claisen, no. Sandmeyer, no. Sandmeyer is Cu2Cl2 in HCl. Be careful. Okay? Please explain. This is a Gattermann, one of the name reaction, my dear. Gattermann-Koch is a different reaction, and this is a Gattermann reaction. Copper should be in 0 oxidation state in Gattermann reaction. Okay? So I guess this is clear. Let's go ahead. Okay. Next reaction you can see. Wait, we can avoid this. This thing you tell. Okay, which of the following methods to preparation of amines will give you same number of carbon atoms in the chain of amines as in the reactant? Okay, so yeah, tell me the answer. Okay, so what I need? Preparation of amines, I need that gives same number of carbon atoms. So carbon atoms should not be increased or decreased, right, in amines, right? So for the reaction with nitriles with LiAlH4 will give you one extra carbon, CH2NH2 you will get, right? Just now we did cyanide in presence of LiAlH4. Next, reaction of amide with lithium aluminum hydride. Yes, for this case. Okay, next treatment with water. This will give you same number of amines. Okay, this will give you the same number of amines in the reaction. Whatever the reactant carbon content and product carbon content will be same for this case. Okay, so yeah, this thing, answer B, option B will be the correct one. Okay, so yeah, we will start the biomolecule. So before starting the biomolecule, I am taking a small break. Again I am telling you, it's a basically 5 minutes break. I will again come back. Just ऐसे जाऊंगी ऐसे आऊंगी. Okay, you people stay tuned. Okay, let's go ahead with the biomolecules chapter. So yes, first question, select the correct statement regarding the amylopectin. Okay, so amylopectin is a polymer of alpha D glucose unit. Yes, that's true, because amylopectin is a component of starch, and starch is a component of alpha D glucose. Okay, so that's gonna be true. Next, it constitutes about 15 to 20% starch. No, that's wrong, because it constitutes of 80 to 85% starch. So that is wrong. Okay, it is water insoluble component, so that is also going to be true. So 1 and 3, right? So option A is the correct one. Okay, so 124, where is 124? Ek minute. 124, what I said? This one. Okay, so which of the following methods of preparation of amines will give same number of carbon atoms in the chain of amines as in the reactor? Okay, that question. So basically, if you see, if you are having the chain with CN, right? If you have the chain, let's say I am having some C, here I am having the CN. The CN is not the part of the chain, it's a functional group, right? So this example I am telling, this one, A. So if you give lithium aluminum hydride, LiAlH4 here, then what it will give you? C. Now this carbon also becomes a member of chain, because it will form CH2NH2, right? Initially it was there 1, 2, 3 carbon, now it becomes 1, 2, 3, 4, right? 1 carbon extra in the chain, right? Initially you would say that is 1, 2, 3. So this is nitrile compound. In the one position you are having the cyanide, right? As a functional group you have to name it. But whenever you are reducing it with lithium aluminum hydride, initially it was prop, now it becomes but, 1 carbon extra in the chain. Okay, but now option B, look at that. You are having, let's say, amide, CONH2. Okay, here what happens, here amide carbon is a part of the chain. Yes, you have to start the naming from here, 1, 2, 3, 4. Further you reduce it, C, this will also be reduced, CH2, NH2. So initially also 4, now also 4. Okay, I guess this is clear, right? This also, if you give lithium aluminum hydride, it is nothing but the nomenclature technique, my dear. Okay, cyanide will not be considered as a part of the chain, but amide carbon will be considered as a part of the chain, right? As a result of this, whenever you are reducing it, the CH2 that you are getting, it becomes a part of the chain itself. Okay. So I guess it's clear to you. Let's go ahead. Okay, treatment with amide with bromine in aqueous solution of sodium. Bromine water if you treat, you will get carboxylic acid, my dear. Bromine water will not give you amine, right? That's why it's not option D. Bromine water, it gives it, it's a very good oxidizing agent, right? So I guess this is okay. Acha, someone is saying amide reaction will give 1 carbon less. That is in Hoffman bromamide degradation. Am I doing Hoffman bromamide here? No, na. I'm doing LiAlH4 reduction. It's not HBD reaction. That 1 carbon less, you told correct. That is in Hoffman bromamide degradation. The reagent, you think about it. What is the reagent of Hoffman bromamide? Think about it, right? So I guess it is clear. Let's go ahead. Okay, wait. Br2NaOH. Sorry, this is the Hoffman bromamide reaction. Sorry. Br2NaOH, this is the Hoffman bromamide reaction. So you will get 1 carbon less here. Option D. Okay, this case 1 carbon less you will get. But I need same number of carbon. Okay, this will not give you carboxylic acid. This is 1 carbon less system. Yes, you are true. Okay, I guess it's clear now. The doubt is clear. Okay, let's go ahead. Yeah. Okay, I guess it is clear. Let's go ahead. the number of amino acid in tetrapeptide. It is a very important question. The number of amino acid in tetrapeptide. So they are asking number of amino acid. Amino acid will be 4, but the peptide linkage will be 3. So be careful what they are giving. Okay, number of amino acid will be 4, but the peptide linkage that is connecting them, that will be 3. Okay, I guess it is clear. Okay, so now you can see the next question. Which one of the following statements is not true regarding plus lactose? Okay, wait, this question is not needed basically. Tell me this one. Okay, which of the following statement is not correct regarding the similarity between the glucose and fructose? Okay, similarity between glucose and fructose. First, both give penta-acetyl derivatives with acetic anhydride. Next, with HCN, both give cyanohydrins. With phenyl hydrogen, both give similar osazone. Both contain aldehyde functional group. Tell me the answer. 129. So basically they are not having aldehydic unit, right? They are not having aldehydic unit in sucrose and fructose, right? One is alcohol, another one is aldehyde, right? So this is going to be the incorrect statement. Okay, so let's go ahead. Okay, very good. D. Let's go ahead. If DNA and RNA heterocyclic base and phosphate ester linkages are at, tell me this one. So basically they are asking in between heterocyclic base and phosphate ester, what is the linkage? Okay, that linkage is in between which carbon? Okay, always remember that linkage is in between carbon 1 and carbon 5. Okay, so option C is going to be the correct one. The linkage is between carbon 1 and carbon 5. Okay, let's go ahead. Next, we will proceed with this question. This is one important question. Okay, which of the following groups includes all essential amino acid for man? So here you can see, in case you don't remember, I am giving you the chart here. Okay, from the chart itself you can just give the answer. So leucine, methionine, lysine, valine, yes, all of them are essential. Option A is the correct one. Okay, next, this question super duper important. Okay, the alpha and beta forms of glucose, they are called anomers. Okay, anomers and epimers, both of them are important. Okay, let's go ahead. Okay, one question I can get, sorry to ask to know now, but what product is formed when benzene reacted under Gutterman reaction? No beta, it was not benzene. It was benzene diazonium chloride. Let me show you. It's fine that you are asking. It is basically N2 plus Cl minus. Benzene diazonium chloride itself. Okay, if you give only Cu here you can see it's copper metal, right, in HCl. Okay, then you will end up with chlorine. It looks like Sandmeyer, but it is not Sandmeyer. In Sandmeyer reaction, what is the reagent you use? Cu2Cl2 in presence of HCl. Okay, here you can see copper is in +1 oxidation state, right? That is the difference. Okay, it's fine that you asked. Let's go ahead. Okay, this is also a very important question. This is also super important question, that thiamine and pyridoxine, what is the name of these vitamins? That is, thiamine is vitamin B1, right? Yes or no? And vitamin B6 is pyridoxine, right? Next question. Okay, super important question. Again, glycogen is a branched chain of polymer of alpha-D glucose unit in which chain is formed in between carbon 1 and carbon 4 glycosidic linkage, and branching occurs by the formation of C1 C6 glycosidic linkage. Okay, structure of glycogen is similar to that of what? Same structure takes place in amylopectin. Okay, because amylopectin is a branch structure where branching takes place carbon 1 and carbon 6. Okay, so amylopectin, it's an important question. Okay, okay, this is also an important question. Which of the following polymer is stored in livers of animals? That's going to be glycogen. Okay, let's go ahead. I want you people to answer. Okay, more you will answer, more it will be rectified. If you are giving wrong answer, you will get to know that the answer is wrong. Okay, I want you people to answer. Okay, yeah. In Gatterman we use copper powder, copper in zero oxidation state. Okay, let's go ahead. Yeah, amylopectin is water insoluble. Let's go ahead. This is also one important question. Okay, 138. Tell me the answer of 138. This is basically sucrose is a disaccharide. One molecule of sucrose on hydrolysis, it will give one glucose, one fructose. That's it. 1 equimolar mixture. Always remember. Okay, so option C is the correct one. Okay, let's go ahead. We will do question 140. This one. Okay, this one you tell me. Proteins are found to have 2 different types of secondary structure, that is alpha helix. Important, super important question. Okay, alpha helix and beta plated sheet. Alpha helix structure of protein is stabilized by what? Tell me. This is going to be hydrogen bonding, right? Okay, very good. Let's go ahead. Okay, let's go ahead with the next question. We will go with this one. Okay, so super important question. Which of the following acid is a vitamin? We already did this question. So basically that's going to be ascorbic acid, that is vitamin C, right? Let's go ahead. Okay, this is an important question again. Super important question. Dinucleotide. Okay, very good. You people are answering. It's quite impressive. Very good. Okay, 143, please answer. Okay, so dinucleotide is obtained by joining 2 nucleotides together by phosphodiester linkage, between which carbon atoms of pentose sugar of nucleotides are linked. It's basically 5' and 3'. Okay, remember this. Okay, so pentose sugar of nucleotides, they are attached in 5' and 3' carbon. Okay, let's go ahead. Okay, this is also important and easy as well. Nucleic acids are polymers of what? 144. Tell me the answer. 144. That's going to be nucleotide, right? Okay, let's go ahead. Which of the following statement is not true about glucose? Okay, so for this case, what you are having, it is an aldohexose. Definitely, it is definitely an aldohexose. Okay, next question is, okay, it is an aldohexose. On heating with HI, it forms N-hexane. Yes, that is also true. It is present in furanose form. It is present in furanose form. So, that is not true about glucose, right? That is not true. Okay, let's go ahead. Next, each polypeptide in a protein has amino acid linked with each other in a specific sequence. This sequence of amino acid is said to be, tell me the answer. This is nothing but the primary structure of the proteins, right? This is nothing but the primary structures. Okay, so next go ahead. Wait, let me go with the important question. This one itself. DNA and RNA contain 4 bases each. Okay, which of the following base is not present in RNA? So that's going to be uracil. Super important question. Okay. Next question you can see. Okay, that is only important. Which of the following B group vitamins can be stored in our body? Which type of vitamin can be stored in our body? That is basically vitamin B12, right? Next, let's go ahead. Okay, which of the following base is not present? We did it already. Again, repetition. Wait. This question. Which of the following reaction of glucose can be explained only by its cyclic structure? This is an important question, okay? Okay, so for this one by one option, let's go through. Glucose form pentacetate. No, pentacetate is for the OH group, 5 OH group is present. Glucose react with hydroxylamine to form an oxime, that is also not. Next, pentacetate of glucose does not react with hydroxylamine, that's going to be the correct one. Okay, this will explain the cyclic structure. Pentacetate of glucose does not react with the hydroxylamine. Okay, it should react, but it does not react because it is a cyclic structure. Okay, let's go ahead. Okay. Yeah, did I tell thiamine? It's definitely uracil. Did I tell thiamine? I don't think so. This is uracil only, no? That's only I marked. Okay, let's go ahead. Okay, so here we are going to discuss hydroxylamine. This we did. Okay, so we can go ahead with the DNF block. Okay. So yes, inorganic, we are going to start with the DNF block element. Let's go. First question, magnetic moment of a transitional metal ion. Just a minute. Magnetic moment of a transition metal ion is basically under root 15 Bohr magneton. Therefore, the number of unpaired electrons, so just put it into the formula, under root n into n plus 2, they are saying equals to root 15. Okay, calculate the n. Okay, so if I just remove the root, n into n plus 2 is basically 15. Okay, so definitely that's going to be 3. Right? So if you just do it like that, 3 into 3 plus 2, that's going to be 15, right? So it's going to be 3. Okay, let's go ahead. Important question, potassium permanganate acts as an oxidant in alkaline and acidic medium. The final products form in the two conditions. They are basically MnO2 they form in alkaline medium and Mn2 plus they form in the acidic medium. It's a very important problem. Remember this. Okay, next let's go. The number of electrons in 3d orbital of this 3, 4 and 5 respectively. Which one of the following ions will have largest value of magnetic moment? So for this case, tell me the answer. Number of electrons in 3d orbital. Okay, so definitely if you are having maximum number of unpaired electron, then definitely you will be having the largest mu value, right? So this is for the Mn2 plus, right? So Mn2 plus will be having the largest number. So 3d5, 4s1. Okay, so that's the reason option that is going to be C. Okay, let's go ahead. Okay, so here you can see the correct order. Okay, the correct order of E0 M2 plus values with negative sign of the 4 successive element chromium, manganese, iron and cobalt. Okay, so if you just look for the chromium, okay, so if you just look for the value, more it is negative, more it has the tendency to go for the reduction. Okay, it is a very good reducing agent. Okay, and more the value is positive, it's a very good oxidizing agent. Okay, so for this case, manganese value, if you just see, it is minus 1.18. Then chromium, if you see, the value is 0.90, right? Then what is there? Successive element chromium, manganese and iron. Okay, this is your manganese, then this is your chromium. Iron is basically minus 0.44, then cobalt is basically 0.28. Okay, so definitely first your answer will come with chromium. Okay, first it will come up with chromium, then manganese, then iron, chromium, manganese, iron, then cobalt. So option D is going to be the correct one. Okay, let's go ahead. Okay, wait. Let me go with the most probable problems. Okay, so this question is an important one. Okay, so this is related to the preparation, right? Na2CrO4. Na2CrO4, if it is treated with something, it will give you Na2SO4. Okay, and some orange coloration. Okay, that is your B. Then it is treated with KCl to give you K2Cr2O7. This is nothing but the complete manufacture of the potassium dichromate. So first here you have to treat this with H2SO4, then you will get Na2Cr2O7, that is orange color. Then if you treat it with KCl, you will end up with K2Cr2O7. So option D is going to be the correct one. I guess this is clear. Let's go ahead. Wait. Okay, this question is important one. V2O5 reacts with acid as well as alkalis to give what is respectively. Okay, so basically V2O5 is an amphoteric. Okay, so it can react with both acid and base. Okay, so you can see it will form VO4 3 minus and VO2 plus. Okay, so this is the portion from where this is taken from NCERT. Basically this is the portion from where you can get the answer. Okay, let's go ahead. Okay, so this question, please tell me the answer. Let's go ahead. Electronic configuration of a transition element. Okay, someone is telling you have done mistake in the previous question. RNA has uracil, not thymine. They did ask which one is not present. Okay, in case they are asking not present, maybe I skipped that term. I am also a human being. So if it is not present, then definitely it's going to be thiamine. In RNA, uracil is present. Yeah, definitely. Okay, I did not see the not term. I did not see, I guess. That's the reason probably I marked as uracil. Okay, I have to go back again. I'm not going back and again I'm not wasting the time. Once you understood this, then it's fine. Okay, so maybe I skipped that term. Okay, that it's not present. Okay, so yeah, let's go ahead. Electronic configuration of a transition element X in +3 oxidation state is Ar3d5. What is the atomic number? We did this type of thing. It's an important one. Okay, so please tell me the answer for this question. So basically, if you add 3 more electron, it will be 3d6 4s2, right? 3d6 4s2. So 3d6 4s2 means 26, right? Let's go ahead. Next, this question is also important, very important question. Okay, the electronic configuration of Cu2 is 3d9 whereas Cu1 is 3d10. Which one of the following is correct? So basically Cu2 is more stable in the aqueous solution. Cu2 is more stable in the aqueous solution. Why? Because enthalpy of hydration is more. It compensates the ionization enthalpy, right? So please remember this, Cu2 plus ion is more stable in aqueous solution though it is 3d9, okay, because hydration enthalpy it compensates, okay. Let's go ahead. Okay, very good. Let's go ahead. Okay, this question. You can see metallic radii of some transition elements are given below. Which of these elements will have highest density? Okay, tell me the answer. For this case, you can see D equals to M by V. From here only you will get the answer. Okay, so copper you can see they are having maximum atomic and ionic radii, hence the maximum mass. Okay, so from here you will get that D is the correct answer. Okay, next let's go ahead. This question is important. Okay, addition of a small amount of KMnO4 to concentrated H2SO4, a green oily compound is obtained which is highly explosive in nature. Okay, it's a very important question. Okay, identify the compound from the following, that is basically Mn2O7. Okay, KMnO4 if it is treated further with H2SO4 it will form Mn2O7. Okay, let's go ahead. Let's go ahead. So this question is this one. This is important. This is also a very important one. Okay, so here we can go ahead. Which one is the disproportionation type? Okay, so disproportionation means a single species will go oxidation and reduction as well. Okay, so here you can see copper plus, from plus it is forming plus 2 and 0. So this is one disproportionation. Yes, so manganese here it is basically, if you find the oxidation state you will get as plus 6. Okay, from plus 6 you will get plus 7 here and this is plus 4. So this is also an disproportionation type. It's an important question, I'm again telling you. Let's say this thing here I am getting plus 7 oxidation state. So plus 7, more than plus 7 is not possible. So option 3 by default is getting cancelled. Okay, now here you can see this is a comproportionation type of reaction. Two species in between something you are getting. This is plus 7, this is plus 2 and here you are getting as plus 4. Right, so this is comproportionation. Disproportionation is 1 and 2, right? So option A is going to be the correct one. I guess this is clear. Okay, let's go. Okay, when KMnO4 solution is added to oxalic acid, it's an important question again. Okay, it's an important one. When KMnO4 solution is added to oxalic acid solution, decoloration is so slow in the beginning but becomes instantaneous after some time. Why? Because this Mn2 plus is generated in between. Mn2 plus is generated in between and that Mn2 plus work as an autocatalyst. Okay, information based question, remember that. Let's go ahead. Okay, so we can go ahead with this thing. Important question, very important. Okay, which of the following is amphoteric oxide? So amphoteric oxide is, this is also an information based question. So that's going to be V2O5 and Cr2O3. Okay, let's go ahead. Okay, interstitial, this is also an important question. Okay, interstitial compounds are formed when small atoms are trapped inside the crystal lattice of the metals. Which of the following is not the characteristics property of the interstitial compound? Okay, so let's go ahead with 167. Options are they have high melting and comparison to that of the pure metals, that's true. They are very hard, that is true. They retain metallic conductivity, true. They are chemically reactive, no, they are inert. Okay, let's go ahead. So here again most important, let's check this question. Okay, KMnO4 acts as an oxidizing agent in alkaline media when alkaline KMnO4 is treated with Ki. Ki means I minus. Okay, it is treated with I minus in alkaline medium. Be careful, alkaline medium will form IO3 minus. Very important zone. Okay, very important question. Okay, I guess this is clear. Let's go ahead. Okay, next we will do this question, important one, very important. Okay, so for this question, look at the question. Highest oxidation state of manganese in fluoride is +4, but highest oxidation state in oxide is +7. Okay, what is the reason? First, fluorine is more electronegative than that of the oxygen. No, that's not the reason. Rather, the reason is the covalent compound that fluorine can form, they can have the single bond. Okay, but oxygen can have multiple bond, means double bond. Okay, that is the main criteria. MnO2O7, if you see, oxygen is making multiple bond with the manganese that fluorine can't do. Okay, so option D is going to be the correct one. Next question, important one. Although zirconium belongs to 4D transition series and hafnium to 5D transition series, even they show similar physical and chemical property because what? Because basically both of them are having same atomic and ionic radii because of the lanthanide contraction, right? This is the consequence of the lanthanide contraction. Okay, so I guess this is clear. Let's go ahead. Okay, so yeah, that's all. Coordination compound. Okay, let's go ahead with the coordination compound. Little fast now. Okay, so yeah, coordination compound, first one. What type of bond is ligand to metal in the complex compound? So that is basically coordinate covalent. Okay, very good, option C. Next, these type of questions are very important. Okay, if the secondary valency of COCl3 4NH3 is 6, then the solution conductivity. Okay, let me make the thing CO. Here I am having NH3 whole thrice, whole 4. Okay, whole 4, and valency. Okay, secondary valency I need to give 6. So secondary valency is 6. Here outside 1 Cl. If you dissociate this, you will get 1 Cl minus and 1 this plus. So it is an 1:1. Okay, please stop me if you are not getting. Yes, I am giving only important questions. Okay, I am not discussing the random questions here. Okay, let's go. I guess this is clear. Okay, given that 1 mole of NiCl2, again important question. 1 mole of NiCl2 6H2O with excess AgNO3 precipitates 2 moles of AgCl. What is the secondary valency? So 2 moles of Cl should be outside. So NiH2O whole 6, all 6 water should be inside, outside 2 Cl. So it's a basically secondary valency will be satisfied by the ligand. So it should be option D. Okay, you did not understand. Which one? You did not understand? 176. Okay. Wait. Acha, this is a very important question. Let me tell you at first. Very important one. This type of question definitely you will get. Okay. So If the secondary valency of this thing is 6, secondary valency means inside the coordination pair you have to keep 6 ligand, right? So let me keep CO, I am taking all the NH3 here inside, okay, and 2 Cl here. See, 6 secondary valency is satisfied. Now one more Cl I have, let it be outside, right? Now if I want to go ahead, then dissociation will give me CO NH3 whole 4 Cl2 plus Cl minus, okay. So how many ion? 1 cation, 1 anion, right? 1 cation, 1 anion. It means 1:1 electrolyte, okay. 1:1 is basically cation and anion ratio, okay. I guess this is clear. Let's go ahead. Just let me know if it is clear or not, okay. Let's go ahead. Okay. This question you can see, what is the sum of the oxidation number of cobalt in this case, okay. So cobalt oxidation number, this is also an important type of question. This type you can get, okay. So for the first case, let me just find out the oxidation state here. So for the water, okay, you will not get any, right? And for the cyanide only you will get, because water is 0, ethylene diamine is also 0. For cyanide only you will get. So X for the cobalt, for water is 0, for cyanide is -1, okay, plus ethylene diamine is also 0, will give you +2. So from here X is coming as +3, okay. Next, this compound. So cobalt, let's take as X. For bromine, I am getting 2 into -1. 2 bromine is there. Ethylene diamine again 0, basically equals to +1. Okay, so X is basically equals to +3. Okay, 3 plus 3, if you add, you will get 6. Be careful whenever you are doing this, this type of thing, okay. Oxidation number is very much important, okay. Even whenever you are going to write the, you know, those IUPAC nomenclature, then also oxidation number matters a lot, okay. Let's go ahead. Yeah, what is the primary valency of iron in the coordination entity of this compound? So primary valency is satisfied by the ligand itself, sorry, it's satisfied by the ions present over there. So you can see how many ions present here. See, here I am outside, I am having 4 Fe, right? So if I just simply dissociate them, I will get what I will get? Fe3 plus 4 Fe3 plus 3 FeCN whole 6, 3 FeCN6, 4 minus, right? This is the dissociation. Now here, if I find out the oxidation state, basically X plus -1 into 6 is basically equals to -4, right? So if I do it, X minus 6 equals to -4, so X equals to 6 minus 4, hence X equals to +2. Okay, option B is the correct one. It's an important one, just let me know if you understood this or not. Let's go ahead. Okay, very good. Okay, it's an important question again. Very important question. Which of the following compounds has enantiomer? Enantiomers, if you want to get, definitely they must be optically active. Optically active when you will get? Optically active you will get when there are no symmetry elements present within it. Okay. So you should not have any symmetry element present in it. So for this case there is no symmetry element. Let me show you. Aluminium here, right? So 3 2s are 6. Okay, so let me show you. For this compound looks like that, and this is oxalate ion. Okay, it looks something like this. Okay, now if you want to draw the mirror image, you will get the mirror image as well. Aluminium, here oxalate, here oxalate, here also oxalate. Okay, this is how you will they are enantiomers of each other. Okay, so I guess this is clear. Okay, you did not understand. Which one you did not understand? The last one? Okay. Okay, beta, simply what I did, no, I just simply dissociated it. Okay, I dissociated it. Always remember, the primary valency is satisfied by the charge. Okay, the overall charge. So that's the reason I need this charge. Okay, so if you dissociate a compound, how will you? I will dissociate. Let me show you. If you are having AXBY type of thing, then you should dissociate this with. You should dissociate it in this way. X A Y plus Y B X minus. That's what I did. That's what I did. It's a 9-10 concept. That's what I did. I dissociated. Okay. Then I am trying to find out the oxidation state of iron. Okay. So that is +2. Okay. So that's what I did. Yes, this is more than enough for the boards. Yes, this is more than enough for the boards if and only if you like the session. Okay, otherwise it's not important. Okay, if you like the session, if you subscribe our channel, then only it's important for boards. Then I can guarantee yes, short 20 marks. Otherwise, no, I can't guarantee you people. Okay, let's go ahead. Just let me know if you understood this or not. Okay, fine. I guess this is also clear. Enantiomer. Okay, let's go ahead. Okay, linkage isomer. Again, important question. Okay, linkage isomerism is seen in the compounds having ambidenticity. Okay, let's go ahead. Okay, so for this case, this is also an important question. Okay, the compound these and these, they are basically ionization isomers. Okay, see the ions that they will form, they are different. Okay, next, let's go through. Okay, which of the following orbitals, okay, very important question. Which of the following orbitals does not belong to T2G orbitals? So T2G means dxy, dyz, dzx. Okay, so for this case, dz square, this is dz square, huh? Like that they have written. Dz square is going to be the part of Eg, right? Let's go. Okay, again important question. Okay, what will be the electronic configuration of D5 in terms of T2G and Eg in an octahedral field when delta O is less than T? Okay, let me do it for you people. So this is your Eg, this is your T2G. T2G, fine. I am having delta O less than P, means pairing energy is more. It indicates I am having a weak field ligand. For weak field ligand, pairing energy is more, right? So in case pairing energy is more, it will not go for the pairing. See, 1, 2, 3. I have total 5 electron to fill here, right? 3 I filled up. Next, whenever it comes to the matter of 4th electron, then the question arises, if I should go there or if I should pair here. But here you can see pairing energy is more. So I will not pair here. I will go here. Okay. So T2G2, Eg2. Sorry, T2G3, Eg2. Okay. So option C is going to be the correct one. Okay. From this MCQ questions, how much marks I get? 20 out of 20. Yes. From the beginning till end, 20 out of 20 guarantee. Let's go. Okay, we have 3 more chapters. We will do very fast. Okay, because you know physical chapters I kept last because tomorrow again we will discuss physical chemistry, though MCQ I will not discuss. I will go for the 2 and 3 marker. So yeah, solution, let's start. Solution, kinetics and electrochemistry, 3 more chapter. You can expect by 10:30 I will be finishing it. Okay, so yeah, let's go. Okay, which of the following statement is false? Let's go. Okay, just give me a minute. Okay, so the relative lowering of vapor pressure of solution is equal to the mole fraction of the solution. That is true because what we write delta P by P naught is basically mole fraction of solute, right? That is true. Passage of solute molecules towards solution side through semi-permeable membrane in osmosis. No, passage of solvent molecule, right? So this is the incorrect statement or false statement. I guess this is clear. It should be solvent molecule. Okay, let's go. Okay, let's go. Yes, I am Bengali. Better you answer the question. Okay, better you answer the question. It will be better for you. Okay, so let's go. Okay, this thing we did initially, I am not repeating this. Which one of the statement given below concerning properties of the solution describes a colligative effect? Okay. Okay, question 179. Let me check 179. Okay, let me check once. 179. This one? No, beta, it's correct only. This is correct only, 179. What's wrong in it? +2 oxidation state. If you just split it, okay, you will get -4 outside, right? So now if you just solve it, means if you just find out the oxidation state of iron, you will get +2. That's it. Okay, anyway, let's go. Let's go back. Okay, few very important question I'm going to discuss here, okay? So yeah, let's go a little fast. Which one of the statement given below concerning properties of the solution describes a colligative effect? Okay, so once it is a matter of colligative effect, that vapor pressure of pure water decreases by the addition of nitric acid. So for this case, what do you think? Vapor pressure of the that is actually wrong. Okay, it increases by addition of nitric acid. Okay, next. Okay, this is basically not a colligative property, that I can tell you. Okay, this is not a colligative property. This is basically an ideal non-ideal solution, you know, because what happens now, decreases. Definitely the answer is true. This decreases, vapor pressure decreases. Why it decreases, you know? HNO3 forms hydrogen bond with water. Okay, as a result of this, if water is bound with the HNO3 by the hydrogen bond, then definitely it will not gets converted to vapor pressure, right? So definitely vapor pressure decreases, but this is not a colligative property. This is because of the hydrogen bonding. Okay, hydrogen bonding is not a colligative property, right? So yeah, let's go for the next question. Boiling point of the pure water decrease by the addition of ethanol. Again the same thing. Ethanol, definitely if you add, then what happens? The boiling point of the, okay, for this case, boiling point ethanol plus water, it will show again, you know, the positive deviation, right? Positive deviation means it is the minimum boiling azeotrope, right? Minimum boiling azeotrope means it is also the boiling point will decrease, right? It will boil in the lesser temperature, right? So that is also not related to the colligative property. So that is also cancelled. Next, if I go, boiling point of pure benzene increases by the addition of toluene. Okay, so pure benzene and What it says? Toluene. So this is a overall wrong statement. Why? Because benzene and toluene, if you add them, they shows ideal behavior. Okay, it is not related to colligative property. Okay, there should not be any increase in temperature or something, no positive or negative deviation. So it's overall it is a wrong statement. Next, vapor pressure of pure benzene decreases by addition of naphthalene. Yes, that's going to be true, because benzene and naphthalene, if you see, both of them are non-volatile, right? When we see the colligative property, when two non-volatile they are added, one volatile, one non-volatile, okay, when they are added and the vapor pressure decreases. Okay, for those cases you can see the relative lowering of vapor pressure, because you can see you can't explain why naphthalene is reducing the vapor pressure of benzene, right? What happens, let me tell you, in phenol, if you are having phenol here, if you are having phenol, now if you are adding naphthalene, so naphthalene molecule will occupy the surface area. As a result of this, it will get accumulated on the surface. So from the surface only vaporization takes place. So if surface area is blocked, then vapor will not come. This is the colligative property, relative lowering of vapor pressure. Okay, here also lowering is there, but reason is not colligative property. Okay, I guess I could explain this thing to you. Okay, so this is the correct one. Let's go ahead. Very important question, my dear, very, very important question. Okay, molar solubility of helium, nitrogen and oxygen are plotted against partial pressure of the gas. Okay, so KH value, if you see, slope is basically KH, right? So P equals to KH into X. Okay, but you can see here X and P, the axis is interchanged, right? It should be P versus X, but here they change the axis, so the trend will also be reversed. So wherever you will be having lesser slope, that will come first. Okay, so helium, then nitrogen, then oxygen. So option B is the correct one. Okay, I guess this is clear. Let's go ahead. Again, important problem, very, very important problem, my dear. Okay, pi 1, pi 2, pi 3. Just a minute. Okay, pi 1, pi 2, pi 3, pi 4 are osmotic pressure of 5% weight by volume solution of urea, fructose, sucrose, and this is KCl. This is not KO, this is KCl. Okay, respectively at certain temperature, the correct order of their magnitude. Okay, how to find it out? You know, in order to find it out, you must need the N value, because pi equals to, you know, pi equals to N by V into RT. So more the number of moles, you will get more pi value. Fine, because let's do it. So pi 1. So pi 1, I am having N value is how much? N value, if I just further divide it, W by M into V into RT. Okay, pi 1 is for urea. Okay, so for all of them, W is same, that is 5 gram. Okay, so if you can see, pi is inversely proportional to the molecular weight. Pi is inversely proportional to the molecular weight. So if molecular weight decreases, pi increases, right? If molecular weight decreases, pi increases. So let me write the molecular weight. For urea it is 60, right? For fructose it is similar to glucose, right? 180. Okay, next is sucrose. For sucrose it is 342. For sucrose, CROAC, it is 342, right? For KCl, how much? 35.5. Potassium, calcium, potassium, right? 35.5 plus how much for KCl? 35.5 plus 40, right? 35.5 plus 40. 75.5 like that. Okay, close by like that. Okay, so if you see lesser the molecular weight, here more. So pi 4 will be more, right? Pi 4, it represents the KCl, right? Pi 4 represents the KCl, so it will be more. Okay, let me check the KCl molecular weight once. Yeah, it's 75 only, it's fine. Okay, so here it should come up to be pi 4 first, then pi 1, right? Then pi 2, then pi 3. Option C is going to be the correct one. Okay, if you arrange them in accordance to that. Okay, let's go. Just let me know if you understood or not. I'm getting your comment in late actually. Okay. Yeah, can't you tell how many marks from model papers? Yes, I'm telling you, from the model papers, you will get 35 marks or passing marks just you will get from the model paper. That's it. Okay. So yeah, let's go ahead. 35 to 40, yes, that much only. Don't expect more than that from the model paper. Okay, it's just to make you pass. Okay, let's go. Yeah, the mixture which shows positive deviation, just let me know which one is the answer. The mixture that shows positive deviation, again it is an important question, that is basically ethanol plus acetone. Let's go ahead. Okay, concentration terms like mass percentage, ppm, mole fraction, it is again one important question, very important question in fact. Okay, molarity is a function of temperature. Why? Because molarity has volume terminology in it. Okay, so if you are having volume terminology in it, then it will be depending upon the temperature. So, what is the answer? What is the answer? Volume depends on temperature. So, option A is the correct one. Next, if you see molecular mass of, again this is very super important problem, okay. Molecular mass of benzoic acid when determined by the colligative property is found high. Yes, that is definitely found high. And why? Because dimerization of the benzoic acid takes place. Okay, so both assertion reason are true and it's the correct explanation as well. Let's go ahead. The mole fraction of the solvent is 0.9, the relative lowering of vapor pressure. So solvent is 9, find out for the solute. Solute is basically 1 minus 0.9, that is going to be 0.1, right? So relative lowering of vapor pressure is 0.1. Okay, let's go ahead. Dissolution of calcium chloride in water is exothermic process, while that of ammonium nitrate is endothermic process. The observation. Okay, so basically the observation that tells about it. Okay, solubility of calcium chloride decreases with increase in temperature and that of ammonium nitrate increases with increase in temperature. Definitely that's going to be the correct one because it is all about the Le Chatelier principle. Okay, the solubility of calcium chloride, if it decreases with temperature, then the process will be exothermic. Solubility, if it decreases with temperature, process will be exothermic. If it increases with temperature, it is endothermic. Always remember, it will utilize the temperature to get soluble. Okay, so let's go ahead. Again, this is a super important question, very important. When acetone and chloroform are mixed together, which of the following deviation? Okay, acetone and chloroform, it shows A and A interaction, they are basically weaker than that of the AB interaction, because here I will get the hydrogen bonding, right? So hydrogen bonding means AB interaction is much stronger than that of the individual AA and BB interaction. Okay, let's go ahead. Okay, which part of the following unit is useful relating to the concentration of the solution with its vapor pressure? So that's going to be vapor pressure. Whenever we deal with, definitely we use the mole fraction. Let's go. Okay, important question, huh? On dissolving sugar in water at room temperature, solution feels cool to touch. Under which of the following cases dissolution of sugar will be most rapid? Okay, so that's going to be definitely whenever you are giving more temperature. Okay, because it is an endothermic reaction, and endothermic reaction require temperature. So if you heat this, then you will get the most rapid you will get. Okay, so powdered sugar in hot water. Okay, let's go ahead. Okay, at equilibrium, the rate of dissolution of a solid solute in volatile solvent is, so that is basically dissolution. Okay, dissolution of a solid in volatile liquid, that is basically equals to the rate of crystallization. Okay, option C. Yeah, let's go ahead. A beaker contains solution of substance A. Precipitation of substance A takes place when so small amount of A is added to the solution. So definitely it will tell that if a small amount of A you are adding over there, you are getting precipitation, means it is super saturated condition. Okay, let's go ahead. Maximum amount of solid solute that can be dissolved in a specific amount of a given liquid solvent does not depend upon, so does not depend upon pressure. Solid and liquid solution, pressure cannot affect it. Gas and liquid, their pressure effects will be there. Okay, let's go ahead. Low concentration of oxygen in the blood and tissue of people, important question. Okay, at high altitude is due to low atmospheric pressure, right? It's due to low atmospheric pressure. Lower the pressure means lesser amount of oxygen will get dissolved into blood. Go ahead. Considering the formation of breaking and strength of hydrogen bond, predict which of the following mixtures will show positive deviation. So positive deviation, yeah, definitely methanol and acetone will show positive deviation. We already discussed about it. Okay, AB interaction is weaker. Okay, let's go ahead. Okay, very, very important. Super important, in fact. Okay, colligative properties depends upon colligative properties depends upon first the nature of the solute, particles dissolved in the solution. No, the number of the solute particles dissolved. Okay, the number, more the solute particles present over there, relative lowering of vapor pressure, and because of the vapor pressure is getting lowered, as a result of this you will see the colligative property is exhibited. Okay. Let's go ahead. Which of the following aqueous solution, again very important, okay, should have highest boiling point? Highest boiling point means I value you have to find out. I value means Van't factor. So for this it is 2. For this case it is, if you just dissociate Na2SO4, 2Na plus SO4, 2 minus. So here it is coming 3, right? For this case it is coming 2. For this case it is coming 2. So definitely option B is going to be the correct one. I guess this is clear to you people. Okay. I guess I'm going a little fast actually here, because one more chapter we have to go ahead, electrochemistry and solution. So that's why I'm going a little bit ahead. Okay, a little bit jump we can do. This thing, it's an important one. Okay, the values of Van't factors in KCl, NaCl and K2SO4, sorry, K2SO4. So if you just dissociate you will get it. KCl is 2, NaCl is 2, K2SO4 if you just break it down, K2SO4 if you just break it down, 2K plus SO4, 2 minus. So 2 plus 1, 3, right? So here 2, 2 and 3. Okay, I guess this is clear. Let's go ahead. Go ahead. Okay, wait. Wait. For this case, we can go ahead with the important questions only, right? Yeah, that's it. Electrochemistry we can go ahead with. Okay, so yeah, let's go ahead. Okay, first question. From the electrochemistry, actually not that many question you can expect. I mean in MCQ we will do very lesser over there, because in electrochemistry major question comes in 2-3 marker. Okay, so yeah, the first one is important anyway. It's a HOTS question. You can get this type of one HOTS question in the numerical, I told you. That's why I don't want to leave it. Okay, EMF of hydrogen electrode. Just give me a minute. Okay, so EMF of hydrogen electrode, let's go ahead. Okay, so let me just proceed with the Nernst equation. E equals to E naught minus 2.303 RT by NF log 1 by concentration of H plus. Okay, so here what you have to do, this particular thing is going to be 0 for hydrogen electrode. So minus this entire thing, if you just calculate, it will come up to be minus 0.059, right? 0.059 log of concentration of H plus minus 1, right? So log H plus minus 1, this particular thing you can take it as pH, right? Because minus 1 will come front. So option D is going to be the correct one. Okay, a little bit tricky one, but not difficult. Okay, again this particular question, again important. Selective numerical we will do, because this is a basically numerical and a physical, I mean theoretical based chapter. We will not go for so many MCQ. Okay, E0 values for Mg2 plus Mg is given, Zn2 plus Zn is also given, and Fe2 plus Fe is also given. Okay, so basically if you just see the value, zinc value is 0.76 and iron value is basically 0.4. Okay, so definitely zinc will reduce iron, because zinc is more negative value. Zinc is towards more negative. Magnesium value is positive, right? So zinc value is maximum negative, right? So zinc can reduce iron. Even zinc can reduce, zinc can reduce iron, and their magnesium will oxidize it. Okay, so this is the correct one. Let's go ahead. Okay, the standard reduction potential at 298 Kelvin. Okay, that's not that much important because we already did this type of thing. Anyway, let's do it. So whenever this type of question will come, look for the maximum negative value. Maximum negative value will give you the most reducing agent, right? So your answer is going to be zinc. Okay, let's go ahead. Wait, okay, this is also an important question, super important. Okay, we are running 250 plus as of now. Okay, yeah, let's go. The reaction which is taking place in nickel cadmium battery can be represented by which of the following reaction? Okay, so for this case it forms cadmium hydroxide and nickel hydroxide, right? So option A is going to be the correct one. Next, let me go for the important question. This one, very important. Okay, highly important problem. Okay, the variation of lambda m of acetic acid with square root of concentration. Acetic acid is a weak electrolyte. So weak electrolyte variation with root C, that will give you this type of curve, right? So basically if you just do lambda m versus root C, okay, weak electrolyte will give you this and strong electrolyte will give you this. By further extrapolating we will get the limiting molar conductivity. Anyway, tomorrow we will discuss this thing in detail. Okay, let's go ahead. Yeah, it will be 300, don't worry. Okay, let's go. Okay, Important question we will go only. Okay, this is one important question. Okay, the difference between the electrode potential of two electrodes. Two electrodes when no current is drawn through the cell, that is called the cell potential. Okay, next let's go through important question only. Okay, this is also an important question, very very important actually. Okay, an electrochemical cell can behave like an electrolytic cell whenever external electricity is more than that of the, external EMF is more than the EMF of the cell, 1.1. Okay, so yeah, this is an important question. Let's go. Next question, this is also an important one. Okay, which one of the statement about the solution of electrolytes is not correct? Okay, conductivity of the solution depends upon the size of the ion, that is correct. Conductivity depends upon the viscosity of the solution, that is also correct. Conductivity does not depend upon the solvation of ion present in the solution, it definitely depends. Solvation will make the atomic radii bigger, hence they cannot travel faster, definitely it depends upon the solvation. So that is going to be the wrong option, not correct option. Okay, let's go. Let's go. I guess that's it. We can proceed for the, okay, this question is important, huh? While charging the lead storage battery, this is an important question, very much important, okay? While charging the lead storage battery, what happens? It basically, PbSO4 in the anode is reduced to Pb, okay? Very important. Next, let's go further. Okay. This question is also important. This type of one question you can expect actually like Kohlrausch Law related. Okay, so you need NH4OH. Okay, I guess you can't see the options. You can check the options. You need NH4OH. Okay, so that is equals to what? Okay, so you can see NH4Cl from here. If you add NaOH and then minus NaCl, so Cl will go and Na will also go and it will end up with NH4OH. Okay, so option B is going to be the correct one. So option B is the correct one. Let's go ahead. Yeah, that's it. So yeah, we can proceed with the chemical kinetics, the last chapter. By the next 15 minutes, we can end up the chemical kinetics as well. Okay, let's go. See, the thing is, what I am skipping is, see, I kept all possibility and full question bank over there. So now I am giving you the most important question. Okay, so I guess you will get comment, don't worry. Okay, because I kept here 350 plus question. Trust me, I kept total 350 plus question along with the previous few questions. Okay, so yes, 350 question for 20 marks. It's more than enough. So I am from then only, from those questions I am cutting. Don't worry. 15 minutes more you give, we will end up. Okay, let's go ahead. Okay, the first thing, 2N2O5, important question again. Okay, 2N2O5 is giving 4NO2 plus oxygen. For the above reaction, which of the following is not correct? Okay, for not correct, we have to find not correct one. Minus dN2, okay, let's write it. So minus 1 by 2 dN2O5 by dt, right, equals to plus 1 by 4 d of NO2 by dt, okay, plus d of, okay, this is equals to d of oxygen, concentration of oxygen divided by dt. Okay, so for that case, if I go ahead, so definitely that's going to be option A. Yes, that's going to be option A, right? No, not option A. That's going to be option B, right? Because if you take that 2NO2 here, wait. No, option B is also not right. Wait. Minus 2 here, if you take that 2 over here, 4 you take that side. So 4 and 2 will be cancelled out. So you will get 2 here. Okay, let me do it for you. So what they are doing, so you can take this 4 that side, right? You can take this 4 this side. So minus 2 d into O5 by dt, right, equals to, I can get here how much? If I just multiply this thing that side, so 4 into d of N2, NO2 by dt, right, equals to, this is as usual, okay, d of O2 dt. So option D is going to be the correct one. Okay, let's go ahead. Okay, is not correct. Wait. This is 2 into this, 4. Okay. This is only the not correct option. Because if you take the 2 here, it will be d of NO2 by dt. But here they are multiplying this with 4. Okay, so option D is going to be the not correct option. Okay, so yeah, I guess this is clear to you. Yeah, option A, B, C, all of them are correct. These 3 are correct only. If you take this 2 here and this below 2, if you multiply there, it should not come 4 here. This 4 should not come here, right? So that's the wrong one. Okay, I guess it is clear because they are asking for not correct. Let's go ahead. Okay, so consider the following statement. Important one again. The rate of the reaction is independent. The rate of the reaction is independent of the reactant concentration. So that's going to be correct, definitely. Following statement, consider the following statement. Okay, the rate of the reaction is independent upon the temperature. So definitely that's going to be wrong because it is depending upon the temperature. Rate law expression, the unit of K for the 0 order. So that's not going to be the correct one, right? That's not the correct one. Okay, I guess you got it, because if you find out for 0 order, so that is basically mole per liter per second, right? So that's not the correct one. Okay, so again for you can see the rate constant of the reaction is independent of the reactant concentration. So definitely it depends. Okay, so they are asking consider the following statement with respect to 0 order reaction. Okay, so correct statement you have to ask. So 1 and 4 are the correct, right? 1 and 4 are the correct. So option D is the correct one. Okay, I guess this is clear. Okay, let's go ahead. 249, it's not A, it's D, my dear. Okay, 1 and 4, both of them are correct. Okay, let's go ahead. Okay, so this is an important question again, very important question. Okay, for the first order reaction, the time required for 99.99% of the reaction, this is basically 10 times. Okay, this basically 10 times. Remember this, there is a derivation that is not needed. Okay, 99% is basically 10 times of the half-life. Okay, let's go ahead. Okay, when the initial concentration, this is also a very important question. Initial concentration of the reactant is doubled the half-life of the 0 order reaction. So basically if you do, we know the formula T half is basically A naught by 2K, right? So definitely if you make it 2 initial concentration, that will be also doubled. Okay, let's go ahead. Okay, let me just go for the important one. This type we did. Okay, this is an important question again. Okay, in collision theory, the chemical reaction ZAB represents. So this is basically the fraction of molecule with energies wait, ZAB, right? This is the collision frequency. Wait, ZAB is called as collision frequency of the reactant A and B, right? So option C is going to be the correct one. Let's go ahead. Again, important question. For a reaction, enthalpy of a reaction minus 4.2 kilojoule per mole and enthalpy of activation is 9.6 kilojoule per mole. The correct potential energy profile diagram. Okay, nothing you have to see, no value is required here, only this negative sign will tell you. Negative sign means exothermic. Exothermic means always remember reactant will be top, product will be below. So option B is going to be the correct one. Let's go ahead. Okay, let me just go for some important question. Okay, this thing, the presence of catalyst, the presence of catalyst, the heat evolved or absorbed during the reaction. So that is basically remains unchanged. Catalyst will not hamper the heat that is evolving or absorbing. Okay, next let's go through. Okay, activation energy of a chemical reaction can be determining by, that is also an important question. Okay, okay, the activation energy can be determined by the rate constant of at 2 temperature, Arrhenius equation, log K2 by K1, right? EA by 2.303 R. Let me write it. So log K2 by K1 equals to EA by 2.303 R 1 by T1 minus 1 by T2. Yes, this one, right? So you need 2 rate constant in 2 different temperature. Okay, let's go. Important problem again. Okay, so what is the problem? Let's see. So consider the figure and mark the correct option. Okay, this is the figure. Activation energy for the forward reaction is E1 plus E2 and product is less stable than reactant. Definitely that's going to be the true one, because activation, if you see from reactant to activated complex, full thing you have to take. So E1 plus E2 and product is definitely less stable. Endothermic reaction. Okay, let's go. Okay. So again, this is an important problem. So for this particular case, a gas phase reaction, definitely tomorrow we will derive this. It is an important question. As of now, you remember it's going to be this one, 2.303 by T log PT by 2pi. This is going to be 2pi plus PT. This derivation we will do tomorrow. Okay. So yeah, let's go. So yeah, let's go ahead. Let's go for an important questions. So yeah, this thing very, very important again. According to Arrhenius equation, the rate constant K is equals to A into E power minus EA by RT, right? So basically for this particular case, option A is going to be the correct one. ln K versus 1 by T graph is going to be like this. Okay, it will give you negative slope. Okay, go ahead. Okay, this question is going to be an important one. Again, which of the following statement is not correct about the order of the reaction? The order of the reaction can be a fractional number, that is true, right? Next, order of a reaction is experimentally determined, that is also true. The order of a reaction is always equals to the sum of the stoichiometry. No, this is only for the those elementary reaction, but other cases it is experimentally. Okay, let's go. Yeah, we are about to end. Okay, initial rate method I am not going further. Okay, this question again important one. Which of the following graphs present exothermic reaction? Always remember, whenever you are dealing with exothermic reaction, reactant should be up, product should be below. Okay, let me zoom it a little. Okay, this is A, this is B, This is your C. See here, reactant is up, product is below. This is the exothermic condition. Okay, here reactant below, product no, it's up, that is also cancelled. Here both of them in the same level. So your answer is going to be this one. So option A only. Okay, option A only, right? Next, let me check for the important questions. Yeah, that's it, I guess. Okay, this one, the last one, okay? Last one for today. Yes, we covered more than 300, almost 350 actually. Yeah, the value of the rate constant of a pseudo first order reaction. Okay, the value of a rate constant for a pseudo first order reaction that depends, rate constant, right? For a pseudo first order reaction depends on the concentration of the reactant present. No, rate constant value they are asking, right? Rate constant value depends upon the temperature, only on temperature. Okay, so yeah, I guess we are done here. So yes, finally you are also relieved, I am also relieved. Actually I am not relieved, I am in tension, because till you will tell me that okay, Monday you gave the paper and you will tell me that okay ma'am we got common, till then I can't be relieved. So yeah, if you really see the hard working done by the teachers, then please like, and if you have not subscribed, then please do subscribe. And tomorrow again in the numerical live session, I can guarantee you common question out of it. Okay, so please make sure you are joining tomorrow's live session as well. Tomorrow in the evening, physical and inorganic will be completely shorted. It's my guarantee to you. So yes, for this day, thank you, good night, have a rest. Before you are going for a rest, just recapitulate everything whatever we discussed. It will be more than enough, my dear. Okay, so yeah, thank you so much, bye bye.